Archiware P5 version 6 product suite in some detail. So let's just talk a little bit more about what we're going to cover. Archiware P5, it's what we call data management software. It's a suite of 4 different modules within the same software suite. It covers archive, backup and replication of your data. It runs cross-platform on pretty much anything, including various NAS storage devices, and it also runs in cloud infrastructure. And the whole thing is relatively easy to set up and configure and monitor once it's running. So those are our kind of core points. Data management software suite, what that means in a little more detail, is we tend to run in media-rich environments. So Archiware P5 is a product that's used in broadcast, media and entertainment spaces more often than not, photography and so on. Generally areas where people are creating fairly large quantities of data and need to protect that data by backing it up, archiving it and replicating it. As I said, there's 4 separate modules that we'll look at in a moment, and we run pretty much anywhere. We work with pretty much any storage devices, so we work with disk, cloud and tape storage, and we're agnostic, so we'll work with any tape vendor, any size of tape drive or library, pretty much any cloud vendor storage, and any kind of disk, whether it's direct attached or however it's attached to your computing host. And it's not a subscription product, so you buy the software, you own the software, you have the right to run the software for as long as you want. There's a maintenance which allows you to download the latest versions of the software and get help with it. And the maintenance is included for the first year when you buy the product, and then you can choose to renew that on kind of add further years to that, so you get help if you need it and you get the latest versions. Now those 4 P5 modules are backup, archive, synchronize and backup to go over there on the right hand side. So today we are going to cover backup, archive and synchronize. We're not going to cover backup to go. There is already a training video on how to do all of that, set it up and use it, which I'll send everybody that's attending a link to. There's just not enough time within 4 hours to go through that product as well. So I'm dropping that product off deliberately. It hasn't changed much in the last few versions though, so there are other videos to learn that one. So I hope that doesn't disappoint anybody. Backup and archive kind of share a lot in common. In fact, I think the next slide helps me here. So backup and archive can write backup and archive data to tape, disk and cloud. So this is the target for your backup or your archive, and I'll explain the difference between a backup and archive in a sec, can be tape, disk or cloud. Whereas synchronize and backup to go, they're just dealing with disk storage, so they're not able to use cloud storage or tape storage, which isn't a problem really, and you'll appreciate that when you know a little bit more. So back to this slide. Backup is all about disaster recovery. So everybody needs a backup of important data, so if they lose it somehow they can get it back. So backup is a copy of all your or a customer's important data. And as I said, it can go to disk storage, LTO tape, drives and libraries, or various different cloud vendors. Generally speaking, you don't keep backups forever because then your backup media set or whatever will just grow over time and become very, very large. And for what reason, you probably don't need to restore files from 10 years ago. That said, if you do want to access files from 10 years ago, P5 Archive is what you need. P5 Archive is about moving data, so taking data from expensive primary fast edit storage or whatever, and moving that somewhere that's cheaper to store and therefore creates free space on that primary storage. P5 Archive is intending to keep stuff forever. So whatever you put into your archive, you'll have forever. That's the intention. An archive includes various functions around media asset management to help locate data. So therefore, that means that you can actually see previews of the data, files, movies or video files or images, for example, and you can search on metadata that's embedded in those files as well. So it has some kind of media asset management functionality built into it. And at the same time, it integrates with lots of third-party media asset management, digital asset management products. So if you're running one of the products, which I'll show you in a sec, you can use P5 Archive as the back end to get data onto tape, disk or cloud. P5 Synchronize is a cloning tool. So this is cloning or replicating data, probably from live storage to some cheaper secondary storage. Could be over a WAN and gets the data off site to a host at a different location. And it's just copying or cloning files and folders. So it's creating the same kind of file structure on the target as existed on the source, which allows immediate access to that data. You don't have to restore the data as you do with P5 backup and archive. And we also support creation of retention of previous versions of files that are changing on the source, on the target, and also you can create snapshots, point in time copies of the data. P5 Backup to Go, which as I said we're not going to cover today, is a workstation backup product. It can back up macOS and Windows workstations, so i.e. laptops and desktop machines, provides a timeline restore, backs up to a central server. That server needs to have a snapshot compatible file system on it, which is either BTRFS or ZFS. So it has to be on a Linux machine, generally speaking, but it could be a QNAP or a Synology which support those types of file systems with the snapshot capabilities built in. So we already saw this slide just illustrating the types of storage that these different modules can access. A little bit more detail on that disk, tape and cloud support that you can write to using the backup and the archive module. Disk support basically anything. So if the operating system can see a disk where P5 is running, then we can read and write that disk. So whether that's direct attached, a network attached, or it's a SAN. Tape support, kind of uniquely, we support pretty much anything. We include our own drivers to support LTO tape hardware, and before LTO we supported earlier generations. The product's been around for getting on for 20 years. We support single drives like this one up here, or single standalone drives, could be connected via SAS or fiber channel. We support tape libraries, which are generally rack mounted and can be basically scaled up to lots of slots and lots of drives within. And we support all the LTO generations. Currently we're at LTO 8. We also importantly support multiple drives in parallel. So you can use, for example, 2 drives to create a clone of data across 2 tapes. If you're archiving, that might be quite useful to have some redundancy because you're moving data to tape and you don't want a single tape failing to cause you to lose data. Also, you can have multiple drives spinning and receiving data, for example, for a backup to increase the throughput speed. So if you've got very fast source storage, then having 2 or 3 LTO drives spinning might give you the ability to save very, very fast into the tape library. Cloud support over on the right-hand side. We support Amazon S3 and Glacier, including the Snowball, which is a device they can send you in the mail and you can copy data to it to get data quickly into the cloud. We support Microsoft's Azure cloud storage, Backblaze B2, which they're a US company that now have an Amsterdam data center in Europe. They have a Fireball, so that's another device that they can ship you to copy data. We now support in version 6 Google's cloud storage. We support another American vendor, Wasabi. I think they also have a European endpoints, and we support any S3 compatible storage as well. So yeah, that includes things like Alibaba, which is like a Chinese storage vendor. Very large tape libraries are possible with P5. Just a quick slide to say 25 slots, 1 LTO drive, that's kind of the smallest library that we commonly see in use. There are some smaller quantum libraries actually. 80 slots, 2 drives is kind of mid-range, and then you can have wardrobe size, hundreds of slots and lots of LTO drives. Providing you have the right licensing with P5, we can support all of that quite simply. P5 runs in a lot of places, operating system installers for Windows, Mac, Linux. This one is FreeBSD, so there's a nice open source things like FreeNAS based on FreeBSD operating system, very similar to Linux, but it's not actually Linux. We support Solaris as a client. We'll appreciate what client means in a moment when we do some installations. In a moment, we will install on Mac, Windows, and Linux, so I'll show you how all of that works. We run on NAS devices and are in the stores for QNAP, Synology, and Netgear. So these NASs, you just have to go into the store within the NAS web-based UI, search for Archiware or P5, click install, and you'll have P5 installed on your device, and then you just need to add a license to activate it or not, as the case may be. And cloud deployment is possible within Amazon Web Services Marketplace. So you can go into the EC2, that's the Elastic Cloud Compute part of Amazon, search for Archiware and deploy an Ubuntu OS with P5 version 6 pre-installed. Set up your IP so you can get some access to it, and then you could start running P5, connecting storage and connecting maybe back into your office locations to back up an archive with a P5 running in the cloud. I mentioned earlier we integrate with various MAM and DAM products, plus various bits of storage. So this is the Archiware's solutions partner page, which you'll find on their website. I'm just throwing up a load of icons just to give you some idea of the number of different products that we are supporting directly and maybe have integrations. Things like CatDV and Axle and Cantimo Portal are media asset management systems where you can push assets into an archive and it will integrate directly with P5 to do that. So in a moment we're going to install, and you'll see this, but everything is configured in a web browser with P5. So everything is done via just pointing a web browser at the IP of the P5 server. You can do this from multiple different machines, and you can also get email job reporting out of P5, so you can see if things are running on a daily basis okay without having to use that web interface. So I'm going to skip this slide and we'll get into doing some installations now. What I've got here is a Mac, so I'm going to be presenting mostly from this Mac, and we are going to be installing P5 on here first. Then we will install P5 on a Linux CentOS 8 machine and a Windows 10 machine, and then we will start configuring and connecting those three installations of P5 together, in terms of one being the server, that'll be this Mac, and then the Linux and the Windows machines will be clients. So the server will be connected to those clients so we can back up and archive and synchronize between the 2 or 3 different hosts. So first of all, grabbing hold of P5 involves going to p5.archiware.com, p5.archiware.com, and visiting the menu and the download page, and then pulling down the installer for either the Mac. There's 2 installers for the Mac. There's a DMG. It's always the new install button that you click on to actually get the installer. There's a TGZ for the Mac. The TGZ is more of a Linuxy thing, but if you want to install on a Mac using the terminal, you can do that. Windows, and then various different installers for Linux. So I've already downloaded the DMG here for the Mac, and if I open that up here, this is the disk image. It has the installer. It has some notes regarding installing on a Mac. There's a few things that you potentially might need to do to allow Catalina to have to allow P5 access to the entire disks connected, because Catalina is quite heavy on security. So if you have issues like that, look in there. There's a P5 companion PDF, which we'll look at P5 later. And this is a backup to go related, so we won't cover that right now. So I'm going to run the P5 version 601 installer package. And when that pops up, this is pretty standard stuff. We just click right through the readmes, agree, and install after providing the admin password on this Mac to allow that software to install. The important thing to say about P5 running on a Mac is it doesn't install into the applications folder like regular kind of front running applications like Microsoft Word or Preview or something like that. P5 runs as a background process on all the operating systems on which it runs. So for example, on Windows, it runs as a service. So that means that when the machine boots up, P5 will start up before somebody even logs in to the machine as a particular user. So you'll see that so P5 picks Safari as the default browser and opens its web interface inside of Safari at the point that the installation completes. So the installation was successful, so I can close the installer, close the disk image window. I'm going to use Chrome as my preferred browser for the installation. So I'm going to close Safari for now. And if I flick to a tab here, click on this P5 localhost bookmark, you'll see that you're pointing the browser at the IP of the machine where P5 is running, in the case of accessing it on your local machine, you can use localhost as a placeholder, or 127.0.0.1, or the actual IP of that machine to get there. And then 8000 is the port that P5 serves up its web admin interface, its HTTP interface. There is also port 8443 that we serve up an HTTPS interface, but we do this using a self-signed certificate, SSL certificate, which is included when you install the product that should be replaced with a real one. So you'll see that Google will complain because it thinks that there's not a proper certificate behind the web server that's running us. So for today, I'm going to stick with port 8000, which is pure plain HTTP, not HTTPS, which won't cause us any certificate issues. Once you can get to the this login screen within P5, you know that it's running and installed okay. So that's it running and installed okay on the Mac. So what I'm going to do next is just run through via a CentOS machine, which is what you can now see. I'm just going to check to make sure that everybody can, I'm not getting anything wrong within the questions panel there. So yeah, I've downloaded the P5. Let's just clear this terminal window. So basically, I've already downloaded the TGZ file from that download page, which you saw a few moments earlier. So one of the Linux download options was a TGZ. So to install on Linux rather, what you need to do is create a directory under user local called AW. So I'm going to create the directory called AW for Archiware and then change into that directory. So now my working directory is user local AW. I've already got that. I've already got the 601 Linux TGZ saved in my root directory. So I'm going to move that into the user local AW directory. So now there's one file in there. I'm currently root, so my user ID is 0, which is root, which means I can do anything that I want to do. So now that I've got the TGZ, which I've pulled off the website, in the right place, I'm just going to do a tar to unzip, expand the file awpst. So that will basically, if I now do an ls, you'll see that's unarchived a bunch of directories and files into this folder. And then to start P5 up, I just run the start script like so. So it's really simple. You just download, unpack the TGZ file and run the start script, and that will set up all of the start scripts within the operating system so that P5 will start up when the machine boots. And then it'll come back and tell you that P5 version 601 is running. Point yourself at the this URL, basically 8000/login, to get to the web user interface, or you can use HTTPS on port 8443. And now if we switch back to our web browser over here, if I point this tab here at my P5 Linux, which has the IP 10.10.0.142 from the perspective of the Mac, that's the IP of that Linux OS, you can see I get a login screen here and it says version 601 for Unix. So Unix being a kind of superset of Linux. So that means that I can now access P5 on my local Mac and also in this tab P5 on that Linux machine. So now we have two installations. Our third installation is going to be on this Windows 10 operating system here, which is about to come to life. So again, I've downloaded the Windows version of P5 from this link here, which has resulted in a zip file. So you can see this is a AWPST 601 Windows zip sitting in my downloads folder. So inside of that zip file, there is an MSI installer package. So if we double click on that one, then Windows is protecting us from an unknown publisher, so we just have to tell that we can run anyway. Now, P5 is actually already installed on this Windows, so I'm installing over the top. So I could either, at this point, repair, which is basically rewrite all of the P5 files, or remove it. So let's just click to repair. Ordinarily, you would say install at this point. As part of the installation, you'll see a command line window will pop up, which does some stuff in the background, setting up a service to run the P5 process, and then it will start P5 up. And once that's done, we'll be able to access the same web interface that we could access from the other two operating systems. That will happen very shortly. And then once that's done, we'll go back to the Mac and make sure that we can pull up the login page for the Windows installation remotely. In fact, whilst that's starting up, let's just flick back to the Mac right now. And if we create a new tab over here, and click on P5 Windows, you can see there it's already running. So now 10.10.0.140 is our Windows installation. 10.10.0.142 is our Linux in this tab here, and the left-hand tab has got the local host installation, which is of course running on the Mac. So with the login pages visible, you can see that there is a default username and password, and they're both admin for a new installation. So what this means is that we're not using the operating system usernames and passwords or directory passwords and usernames to authenticate into P5 anymore as of version 6.0. All of the authentication into P5 is now done against the internal P5 user database, which on a fresh installation will just contain one user called admin, for whom the password is admin. So the reason for this change in version 6 is simply that we're running on so many different platforms and NAS devices and so on, it becomes almost impossible to keep working integrations with all of the user databases on all the different operating systems, and probably doesn't add that much benefit for most people. So now you're just using the accounts that you create within P5. If you upgrade from an existing P5, all of the users that had been logging into P5 are carried across, but you'll need to reset the passwords. So at this point on this Mac localhost installation, I'll do as I'm told and log in as admin, and it reminds me then to change the password to something more secure. And upon first logging in, you can do that by the top right menu here. You can change the password, and I can provide admin as the current password, and then I'm going to change that to a password familiar to me that's a bit more secure, and confirm that I want to do that, and then that first step is done. Okay, so when you first log in to a P5 UI like this, you'll be prompted to enter a license. Now, the P5 runs either as a server or as a client. So we're going to run P5 as a server on the Mac, but on the Windows and on the Linux machines, we're going to run as a client, which means we don't need to enter a license. You don't need a license to run as a client. And that will make a bit more sense when we add those clients into our server. So for the clients, P5 needs to be running on contactable on port 8000. But you don't need to provide a license for that particular machine. That often catches people out. So I've got a text file sitting around here somewhere, which has got a license key. This is an evaluation license key that as an authorized reseller you can get hold of from Archiware or from myself. You will either be entering an evaluation license, which come in 7 or 30 days, or you'll be entering a purchase license because a customer bought a copy of the software, and you're entering in a real serial numbers that they purchased. So let's begin by just inputting this channel evaluation license. So I click on enter license. Down at the bottom, I will add manually. And first thing I have to do is just select that this is a channel evaluation. You can see this product menu here contains all of the possible purchased product codes. Down at the bottom, and then at the top there's a 5 or a 30-day or a channel evaluation license. It's the channel evaluation license that we have here. The expiry date for this license is just in a few days, on the 1st of June, and the license key is this string of characters, and then I hit apply. So basically the serial number is always the same for a channel evaluation. You don't need to fill that in. The expiry date is as provided in the license text, and so is the checksum key. So when we apply that license and close that window, you'll see that previously all of the module configuration buttons or tabs were grayed out at the top. They're now colored in because that indicates that this evaluation key activates all 4 of the modules, and now so that you can now click on those to get to the configuration for backup, synchronize, and archive, and also restoring data over here. There's a button here which gives us access to what we call the job monitor, where you can see jobs that are scheduled to run or are running or have completed, and then a history that allows you to see what's been happening on this server back in time. And then this menu over here contains documentation. About P5 tells you in a window which version you're running, which build you're running, tells you importantly what your host ID is. So the host ID is unique to each installation. It's based on the Ethernet hardware. So the host ID is needed to generate a permanent license from a serial number that you've purchased. And just very briefly, you'll also find in here that there is a link to the license registration portal, which will open in a new window and takes us to the Archiware portal website. If you're an end user or a reseller that's sold P5 license, you'll be sent a serial number and a validation code. You'll need to create an account in this Archiware portal site, and then from there you can generate your keys. So for example, there's a how-to here on how to, once you're logged into the portal, make a license registration, which requires that you enter the host ID from the machine that you wish to run the P5 serial number that you purchased on, with a validation code and a serial number that's sent in the paperwork. And then ultimately, after various steps, you'll be sent something that looks very similar to this, but it will contain your unique license key. It will not contain an expiry date because it's not subscription software, it runs forever. And then you enter that into your software to activate it. So that, if I just close that tab, that was available from license registration, but we're using an evaluation license, so we don't need to register any real keys. Any resellers listening will hopefully be familiar with the license registration process. Tech support, products updates, this is links back to Archiware's website, and some of this other stuff in here we'll cover off a little later on once we get going. So we now have a licensed P5 running on this Mac. What we're going to do first this morning is cover doing a backup to a standalone tape drive. I have a standalone drive here with me on my dining room table, which I'll turn on in a minute. It's quite noisy, so I'll turn on when I need to. So what I'm going to do is run through doing a backup of data from both the Mac and also some data from the Linux machine. And so we're going to add the Linux and the Windows machines as clients into this installation. So you'll see under backup and also under synchronize clients. So under backup, synchronize, and archive, the client list is always common. It's the same client list. It just applies to those three different modules. And currently the client list has got the local machine in it, localhost. So the installation of P5 on this Mac counts as our first client, as it were. So this is the local machine, and it's through localhost that we will go and locate data attached to this this Mac operating system. But we might also want to do backups and archives of the Linux machine, in which case we would add a new client by clicking the new button at the bottom of this list, and the Linux client has this IP address. I've just put it in here to remind myself what it is. So the client's name is going to be Linux, and the IP address of the client is 142. And because I didn't change the admin password on that installation, I won't change it. I'll just use admin as the password and apply. And at that point, P5 running on the Mac is connecting to the P5 running on the Linux and authenticating. And at this point, we know everything is working with regards to P5 being installed. When the P5 on the Mac is talking and receiving or sending data to the Linux machine, you can compress, encrypt, or limit how fast that data is put on the IP network via those three menus there. But in this instance, I'm not going to make any changes. Compression and encryption both require a certain amount of CPU, which will make your machine busier and might slow down the throughput of data if the network is very fast and maybe the CPU isn't so fast. So applying that change and closing that window, I now have a Linux machine in my list, and let's do the exact same thing to get the Windows machine in here. So this is Windows, this is the IP address of the Windows machine, this is the same default password because we didn't change it, and then close, and now we have 3 clients in the list. From here, it's possible to just do a ping on the client to make sure that P5 is running, is active, and it will tell us, in fact, what version of P5 is running on that Linux client. So you can just check that everything's okay with it. You can also restart P5 running on that client. It'll just restart the P5 software, or you can enable or disable that client within the list, because you might want to, you might only have a limited number of licenses, and you might want to activate one client whilst disabling another. So that's clients briefly. What we're going to do now is just briefly discuss the concept of pools and volumes, which you'll see down here, pools which are both currently empty, because in order to write a backup to a tape, which is what we're going to do next, we are going to need to prepare an LTO tape for writing of backup data. And we do that by first creating a pool and then creating a volume. So if I can just find my pen, I'm going to flick over to my virtual, where's it gone? Pixelmator. Okay, so let's get rid of that. And let's just talk a little bit about pools. Okay, so a pool is basically a container for storage. So there's a container. This is going to be my pool. And a pool, basically, when you create one, there's a few things that you attributes that you assign to the pool. One is this going to be used for backup or archive? So a pool is either a backup pool or an archive pool. It can't be both. So it has to be one or the other. Also the type of storage. So it could be a tape pool, but it could be a disk-based pool. And disk also encompasses using cloud storage, which we'll cover off later. So you create the pool and you say, in the case of the one we're going to create, it's going to be a backup pool and it's going to be for use of tape. And then we're done. Then we've got we've created a pool. So we might call this tape backup as the name for the pool, tape backup. And then once that's done, of course, I've got this LTO drive, which looks something like this, sitting on the table in front of me. And I've got a tape, an LTO tape, which I'm going to put into the drive. Whoops. And I want to write some backup data to that tape, which means that I need to make that tape a member of the pool that I created, so that that pool has one tape in it, and that might be called tape number 1 within the context of the pool. And then the idea with pools is that as I want to expand the amount of capacity, I can add more tapes, and I can put different tapes in the drive at any given time, and then I can have the capacity within the pool increasing by the amount of data available on each tape. My LTO drive that I'm using is rather old. It's an LTO 5 drive, which means that it has 1.5 terabytes of capacity per tape. So if I had 3 tapes, that would be 4.5 terabytes worth of capacity in the pool by virtue of the fact that there are 3 tapes in there. Now in the Archiware vocabulary, these are not tapes as such, but they are called volumes. Okay, so we create the pool, and then when we take the first tape that I have in the tape drive in front of me, we create a volume by doing something called labeling. So what I do is I say I want to do a label job, and I specify my LTO 5 drive that I want to label in, and I specify the pool that I want to label the tape into, which will be the tape backup pool, and so on. So I basically go to the tape drive over here, I say label me a tape, provide it with a blank tape, and then I say specify the pool that we already created, and then this tape will be created in this location here, and it will be it'll be the first tape in this pool. So let's do that now in the software. We'll come back to pools and volumes in a little bit, and we're going to look at disk-based storage, and volumes exist on disk or as tapes. So a tape can either be a physical LTO tape, or it can be a collection of data on disk. So I'm clicking the LTO drive, which you might be able to hear in the background as a bit of a noise. Now, the first thing that we have to do before we create the pool or create the volume is add a standalone tape drive to this P5 installation. We'll come back to what Storage Manager does in a little while, but first of all, we're going to use a standalone tape drive. So I'm going to click on New Tape Drive at the bottom, and P5 will detect the drive which I've just switched on and tell me about it. So here it is, it's the Tandberg LTO 5 half-height drive. If there were more than one drive attached, then I would see and I would be able to select. Tape drives work over either fiber channel or SAS interfaces. Because this is a Mac, I've got a Thunderbolt connection to a bridge device, which gives me Thunderbolt on one side and fiber channel out the other, and then that goes into the physical tape drive that I've got here. So I'm going to click on Next. The next step is just to identify what I want to call the drive. I'm happy with the default, and also what generation of LTO5 it is. It will, not generation of LTO5, what generation of LTO, and it will pick that for me. And then I click Install, and then there's an option here to do the labeling that we just discussed automatically for me, so I could label for backup and archive, and what that would do is it would create the pool for me, and then it would label this tape into that pool all in one step. But it's better if we do this the long way, because you'll have a better understanding of how that works. So we'll say don't label at this point. Okay, so I'm just going to push the tape into the drive that I have in front of me. So that's ready to be labeled. And now we will create that pool that we spoke about. So the pool, we click on New, and we will call this LTO Backup. So it's clear that it's a tape and it's going to be used for backup. So it says here used for backup or archive. So it's obviously going to be used for backup. And the media type in this instance will be tape. And then I can apply and close, so that we can see in the list we now have a single pool called LTO Backup. The media type is tape. It's going to be used for backup. It has 0 bytes of capacity because there are currently no volumes, i.e. tapes, inside of that pool, and therefore there's no capacity available, and there's no capacity free, and there are 0 volumes, as just alluded to. So in order to create a volume in the volume list here, and so that we see a number 1 show up here and 1.5 terabytes of free space, we need to label the tape that's in the LTO drive to make it a member of this pool. So I go back to my LTO drive, which now shows up under standalone drives, and then I use the label button at the bottom here to choose the pool that I want to make this tape a member of. Because this is a standalone drive, there's no selection of slots or anything, there's just whatever tape is in the drive at the moment. And the exception, possible exceptions, basically means we will check the tape to see if it has Archiware data written to it previously. If it does, if it's previously been labeled, then we will skip it. So I have to tell P5 that I deliberately want to erase whatever's on this tape right now. So I'll click on the label button, and you'll see this little panel here says that it's scheduling a job. Use the job monitor to monitor execution. So the job monitor is available via the button, which then changes down here from start to monitor. So if I click that, the job monitor window will pop up, and you can see there is a job running at the top with some information about what's actually happening right now. So it says it's labeling. Labeling consists of writing some data and verifying that we can read it back a couple of times to be sure that we have a working drive and a working tape, because if we don't really want to go any further than this. And then once it's complete, the job will drop down to the bottom with a green dot against it indicating that it was successful. So running or scheduled jobs show up at the top of this window, and completed jobs show up at the bottom of the window. I'm just thinking, actually, if any questions are occurring to you all whilst we are going through this content, you're welcome to type them in. I'm not looking at the questions while I'm talking. That would be multitasking, but I will go back and check the questions periodically and try and answer any that you're typing in there. Okay. So the labeling finished, so let's close the job monitor window. The job monitor window, of course, is available from here, job monitor. So we can always go back to the job monitor window and see what's going on. In fact, I'm just going to leave it at the back there. And now, if I go look at the pool, you can see that there is one LTO5's worth of capacity in this pool, and there's one volume. So if I ejected this tape now, put another one in and labeled that, I'd have about 3 terabytes and 2 volumes. And then each of the volumes will show up under the volume list. So you can see this is the tape in the drive right now. So it actually says location is the Tandberg LTO drive, because that's where it is. The tape is appendable, which basically means that it's not full. There is space on this tape to write more data until it becomes full. So the mode is appendable. The amount of space that's been used so far is of course nothing. And then we get a total at the bottom across all the volumes that we have listed. So I'm just going to label one tape in this instance. We will flick to using disk storage quite soon, and then I can switch the noisy drive off, but I just wanted to give you some experience of physical hardware. I'll also talk about what happens when you're using a tape library. I don't have one of those here, but I can show you what the UI looks like for adding a tape library. So now that we have a pool and a volume, we can go create ourselves a backup plan to back up some data to the pool, and therefore the tape that's currently in the drive. So a backup plan is basically a configuration of what it is that you're wanting to back up and where it is that you want to back it up to. So in the instance of what we've got here, if I just make myself a bit of space here, delete that stuff there, and go back to my brush. A backup plan is basically a configuration that says what is it that we want to back up. So that will consist of like the Windows machine plus a folder, a list of folders, and the Linux machine plus a list of folders, FLDR. So that's the what, consists of machines and the folders that you want to back up from those machines. And then there's the where, which will basically be a target at a pool. So we might say, yeah, this pool here that we've already labeled our tape into. And then there'll be a when stroke how question as part of the backup plan. So that will be sort of midnight, 12 o'clock midnight. That's the when. And then the how will be, oh, I want to do an incremental backup on a Monday, Tuesday, Wednesday, Thursday, and I want to do a full backup on a Friday, that kind of thing. So this is the scheduler that's basically determining what kind of backups we're going to run on what dates. And I will, when we've done a backup, I will explain what incremental and full means in this context. You may already know that, but it's quite simple for me to explain that to you. So let's make a backup plan by clicking the new button that's now becoming familiar to us at the bottom. Then we'll give this a name like LTO backup and apply that. So the backup tasks is the what, and the what consists of a client, i.e. localhost, Linux or Windows, and the directories to back up. So to add an entry into this backup tasks lists, we're clicking on new, and we are going to choose which host it is that we want to back up. So let's start with localhost, which is of course this Mac, and we will then choose some files. So this this box here contains all by default. So if you don't do anything else, it'll back up everything on localhost, which would obviously take some time. Alternatively, you can type in a path here, like backup everything on the desktop, add that to the list. Or you can use this button here, which is the file picker button, 3 dots. You'll see this appearing various places within the UI. And this will allow us to browse any attached file systems to this Mac. So what I'm going to do is browse down to the preferences folder. So and click select off of the root partition. This is the directory that I'm interested in backing up from this Mac. This is the preferences folder. Lots of small files that change frequently, so it won't take long to back up, but at the same time it will there'll be files that will change. So if we run another backup, there'll be things changing that the backup should pick up. So let's just go with that one folder for this backup. I can obviously add more if I wanted to. Down at the bottom, it's possible to create what we call file filters, which are little configurations which say don't back up any files that have got .mov at the end. So you can select files via like a wildcard or regular expression matching of file names and folder names, or you can match on paths, or you can match on dates, modification dates, and I'll run through filters in a little while. So we'll apply that first backup task to the list, and then just to make it interesting, we will add something from the Linux machine as well. So on the Linux machine, I'm going to browse, and you can see our file picker is now showing me the file systems on the the CentOS 8 machine. And let's just back up the etc folder, add that to the list and apply that one. Okay. So if we run this backup, well, what we want to do is run this backup now. In order to do that, we need to create a backup event. And the backup event, if I click on the new button, looks like this. So a backup event is either an incremental, a full, or a synthetic full backup. I'll explain also what a synthetic full backup is. It's not that commonly used, so don't worry particularly about it. Let's just do an incremental backup. We want this to start at 10:30, that's fine. If I wanted to, I could say, well, on a Monday by 9 o'clock in the morning, people are using this storage that we're backing up, so we want to make sure the job's not running. Therefore, P5 will shut the job down after however many hours specified and allow the next run of the backup to continue saving anything that's changed because it's an incremental backup. And then I choose the frequency. So every day, every other day, by putting a 2 there, or just on certain days of the week. Might be that you want to run a full backup every weekend or every month. If you want to do monthly, you can choose a 1 day in the month, which allows you to pick any day within the month. Let's stick with weekly. You can make an exception, which is basically the same as this bit here, but allows you to basically punch a hole in an everyday backup, saying every 3rd Wednesday you don't want it to run or whatever. And then at the bottom, we're choosing the target pool. We only have one of those, so that's pre-selected for us. There is the ability to have a list of pools from which Archiware will work out which pool has volumes available, and will use the first pool from the list that has volumes available. This is useful in the case of using a tape library where you're shuffling tapes in and out the library on a daily basis to take tapes off site. Archiware, selecting 2 pools here, it will use the tapes which are in the library on any given day. And if the tapes aren't switched from one day to the next, it will keep using them. But it will maintain the data on those sets of tapes independently, so any set of those tapes can be restored from. So let's apply that our backup event, and then we will run this. So I'll apply all of the changes that we've made so far, and I will highlight this job here, and I will click on Start Now and confirm I want to start. And then you'll see in the background the job monitor window now has 2 backup tasks, because the backup plan had 2 backup tasks in it, one for Linux and one for localhost. So you'll see each one of those is now spinning, and this pool will allow data from multiple backups to be written at the same time. And we'll see some stats whilst these jobs are running, but they won't be running for long because these are not big directories. So you'll see in the job monitor, there will be 2 jobs running, one for each of the clients. And in addition, there will be 2 save backup index jobs that you can see have completed, which write additional data onto the tape regards the configuration, so all of the settings within P5 and also the backup index databases that go with the backups get written to the tape, so that if you did need to recover everything from the tape, you could do. I'll explain a little bit more about what a backup index is in a moment, because we'll start looking inside of one. So you can see everything finished with a green light. The 2 pieces of jobs here which save data are telling us how much data they saved, so just a few megabytes. And yeah, you can see how long they took to run. So the result of that is that we will now have some indexed data about what was backed up available to browse by clicking on the Restore tab at the top here. So under Restore, we have the option to browse either backup or archive indexes. So if we click on backup indexes, we have an index for each of the 3 clients that we have the ability to back up. So for example, if we look under Linux, we will see our etc folder that we backed up, and inside of that we will see everything in that folder that was there. And if we go inside of here, if we were interested in restoring this file here, for example, we could add that to our restore selection via the button at the bottom. So I've now got fonts.conf in here, and then I can come back and maybe choose to add a folder, to restore, and so on. So I can build a restore selection in here and then head off to actually perform that restore job. Okay, I won't restore anything from the Linux machine. I'm going to go back to the top and let's have a look inside of localhost. So on localhost, which is this Mac, remember we backed up the preferences folder, and the preferences folder contains loads of little plist files, currently sorted by size. But if we sort by modification date, you can see I can get to the point where I can see 20th of May at 9:43 at the top. So this is a file that was modified a few minutes ago, and then it was backed up by that backup job. So the backup index basically lets you browse through what looks like the file systems that you backed up from, and you can sort, you can search. So for example, if I wanted to find knowledge agent, I could do a search in the index for name contains knowledge, and that will immediately come back with the results, and then I could add stuff to my restore selection from my search results. The indexes are actually existing alongside the P5 installation on this Mac, and they are actually stored as SQLite databases, relational databases via several tables. So yeah, that's just a bit of an aside. So that's why the searching is quite fast. Obviously, we don't have a lot of data to search on, but there's a proper database underneath, which is quite quick to search. So yeah, that's the search button. Now, what I'm going to do before we do any restores is if I run another backup, another incremental backup, some of these files will change because every time I run an application on this Mac, for example, system preferences, there'll be a plist file which will get updated. So the first backup that we ran, although it was an incremental backup, which is looking basically for files which we haven't seen before, or changed files, the first incremental backup will have saved everything because this is an empty index. And when we run the backup, we're comparing the file system with the index to work out what we don't yet have. So if I go back to my backup plan here and I run the incremental backup again, so just highlighting that backup event and saying start now, what will happen is P5 will look at the index, look at the file system again. Let's just look at the job monitor window, and it will work out across both of those machines what has changed, what needs to be saved to bring that back up to date. And in the case of the localhost backup, I think some of those plist files will have changed. So probably the case on the etc folder in Linux as well. So there will be a few files saved, but probably not many. I think I saw 15 there being saved. So once that job's finished, we'll be able to go back into the backup index and we'll be able to see 2 snapshots in time because we've run 2 backups, and we'll be able to see the differences between the 2, just to give you an idea of what the incremental backup actually does. So once those 2 jobs are finished, updating the index, we will be able to go back in and browse it again. Okay, so it looks like it's about there. So actually, let me just, oh, that's the Linux one that's finishing. So if I go back into restore localhost and just close that restore selection and drill down again into the preferences folder here, then at the very top, you'll see the most recently modified file in the index now is from 9:57, which is just a couple of minutes ago, or even 1 minute ago. So this file, madrid.plist, was saved probably the first time we ran the backup, assuming that it existed, and it's been saved again. So if I double click on this file, I will get the properties window for that particular file, and I'll be able to see that this Madrid plist file was indeed saved. It was backed up on the backup date column at 9:52 and 9:57, and then the modification date, which is the modification date of the file system, was previously 8:57, and now it's 9:57, a whole hour later. So from here, I have a restore button, and I could choose, if I'm only interested in restoring that one file, I could say I want this version of the file or this version of the file. The other way of accessing the fact that we've got two different snapshots of data is via this menu here. So you can see that by default, the index will show you the most recent snapshot of whatever folder you're looking at. If I click back to the 9:52 backup, then you'll see the Madrid plist is no longer the most recent file. The most recently modified file was at 9:43. So that means that I could go back and I could restore the whole preferences folder from the 9:52 snapshot or the 9:57 snapshot. The index maintains these two snapshots and all the files and the state of those files at that point in time. So this means that once your backup's been running for many weeks, you're able to go back in this interface, pick a date, and then see what was in a particular folder or location on that date. If there are many different snapshots, then the more options window here will allow you to see a list of all of those points in time. And if it's very long, you'll get a date widget that will allow you to pick a date range, maybe January 2019 to February 2019, and then you'll see all the snapshots within that date range to pick from to then attempt to restore files from. At the same time, this index options allows you to reduce the index that you're seeing down to a particular pool and then down to a particular volume or volumes within that pool. So we only have one pool and one volume, so the options here aren't that great. But if you had two pools, maybe you've got an on-site and an off-site tape pool, you would be able to filter the index so that you're seeing data from one particular pool, and then therefore when you select data to restore, it will require tapes from that pool to restore from. I want to say a little bit about the way that the index works. So let me just flick to my graphics tablet and let's just remove what we've got here. So in the case of a backup, we've got the file system that we're backing up. So that's some kind of disk that's got lots of folders and files in it, like so. And then we've got over here, we've got the LTO tape or whatever storage that we're writing to. Could be disk. Basically, consider it to be a volume, it's a unit of storage for P5. And then we've got the concept of the index, which, as I said, is a database, and it's the index that we were browsing when we were choosing things that we might want to recover from the backup. And you can think of the index as basically as a table of files that we've backed up. And in this index, we will be storing things like the file name and the path that the file came from, and the date and the size and all of that kind of information going across here. And we will also store things like the volume. So like if this is our volume number 1, then a file might be on tape number 1, and then there'll be a block position on the tape and so on, so that we can locate exactly where this file has been stored. So the first time we do a backup, maybe we save 1,000 files, and we're writing 1,000 files into this index. So we've got lots of entries in here for file names and paths and dates. And then 24 hours later, what we will do is we will look at this file system again. Every file that we find on here, we'll find it in the index and see if the file has changed. Maybe the date, the modification date's slightly different. Maybe the size is slightly different. And if it is, then we will add another version of that file to the index. So then we might have that file appearing up here and further down here. There's two versions of the file because the file has changed. So the general point is that we'll always compare the file system with the index to work out what we need to save in a backup. and it's the index that you are browsing and searching via the web interface to make restores. So coming back in here, if we decided that if we're browsing into this preferences folder again and we're looking at the recent snapshot, the restore process would be to select some files, add those to the restore selection. Maybe further down here there's a whole directory that I want to add into my restore selection. So I choose everything that I want to restore. It could just be a top level folder that I'm wanting to restore to pull lots of data back, or it could be an individual file that I want to recover because somebody needs to get the file back from yesterday because they deleted it or changed it or something. And then when I'm ready with my restore selection, I'll elect to restore to button, which brings up this window here. And this basically lets me choose where I want to restore to. The default will always be restoring back to the original location for each of the files, but I could relocate to a directory. So maybe I want to come in here and browse for my desktop on this Mac. So David Fox, choose the desktop folder to restore to. I could restore to either the Windows or the Linux client and browse for a folder on either of those two machines as well. And if there's a conflict, i.e. if the file that I'm about to write and restore already exists, then do we not restore it? Do we add something to the end of the file name to so that we're not overwriting files? So if I click on the next button now, what happens is P5 will work out that there's 109 files, that's 35 megabytes to restore, and the files are going to be restored onto my desktop. Actually, I don't want 109 files restored. Actually, there's a folder, isn't there? So I'm just thinking I'm going to make a mess of my desktop, but let's go ahead and do it. So let's hit start. And if I monitor again, there will now be a restore job running. This requires, because this is a physical tape, it requires rewinding the tape, checking that the tape is the correct tape, because I might have changed that tape while it wasn't looking. So it makes sure it is the right tape. I just expand this for some more detail. And then once it knows that, it will wind the tape out to the correct blocks for the files that we are restoring. And then I should see about 6 files and a folder showing up on my desktop, so you can see those there. Yeah, that's this stuff that just appeared, and inside of this folder there's probably quite a few files because it said there was 109 files in total. So there we have it. So let's just delete those because we don't really need to keep those right now. Okay, so that's how you do a restore from a backup. That's how you search the backup index to locate maybe old copies of files. That's how you look through various snapshots in time across backups that you've done historically and just restore data from those backups. I need to explain to you the concept of an incremental and a full, which I can do via the diagram that we've already started here. So the idea with a full backup is that we always save everything. So the backups that we just did were incrementals. With a full backup, we don't do a comparison with the index to see what's different. We just take the folders that you've asked us to save, or the entire disk, and we save the whole thing. An incremental backup is the one where we just look for the differences and we save the differences. So if you think about this in terms of going through time and the way that you might work with a backup, let's say we have some number of volumes. So these could either be tapes or disks or cloud-based storage. Remember, these are just volumes rather than specifically tapes. And we've got some storage up here that we're doing a backup from. Let's say we've got 1 million files, not uncommon, that we want to back up. And let's say these are if these were LTO 8 tapes, these would be 12 terabytes worth of data per tape. So this is the latest generation of LTO, would be LTO 8. And so let's say we've got 15 terabytes of data to back up. So the first time we run our backup, whether we do a full or an incremental, it's going to save 15 terabytes worth of data. So these are 12 terabyte tapes. So we're going to fill up tape number 1. and we're going to partially need to use some of the second tape to get the extra 3 terabytes. So we've got 1 and a bit tapes now written, and that was effectively a full backup because we needed to save everything. Now the next day, if we're doing an incremental backup, however many files and folders have changed on this disk in 24 hours will need to be added to this tape. So this will just be a small slice of data that's being added to the tape. And then we go along doing incremental backups, which probably would take quite a long time even to fill up the second volume, because incrementals are nowhere near as big as 15 terabytes normally, depending on how much data the customer is changing. So we will continue in this vein maybe for a month or two. And if we continued till we run out of tapes, so here we've got 3, 4, we've got 5 LTO tapes. If we do nothing else, we'll basically get to the point where we've filled up the 5th tape, and then we need to buy another tape to keep going. But what if we wanted to just stick with 5 tapes and come back and reuse the oldest tape and not keep our data forever? Well, that's a possibility, but you would need to take another full backup before you could do that. So remember this data here with the vertical lines on it, that's our full backup, and then all of the incremental backups are kind of additive to the full backup. So to do a restore of a whole folder, for example, we would need some of the incremental data and some of the full backup data. So in order to be able to reuse the first tape that we wrote, we need to make sure that we've got a second full backup somewhere in these, across these volumes, that we can go back to restore, but then we can delete the earlier full backup. So basically, if we took another full backup after a month, so this would be the vertical line section here again. So there's a full backup, and then it's starting to go into the 4th volume. Then we would continue to do incremental backups after the second full backup. Then when we finally get to the point where we've filled up our 5th volume, and we don't want to have more than 5, we are now able to come back and destroy the first volume that we wrote, remove all of the data on it from the index, and effectively make that a new volume, a reused volume, so volume 6. And none of the data that was on the original volume is now needed as such, because we have a second full backup existing here and here. So basically at a point in time over here, if we wanted to recover data, we can recover data back to the beginning of this full backup point in time here, but we can no longer go all the way back to the very first full backup because we've started to overwrite those tapes. So this is a way that P5 works with backup, and in order to do this, you have to configure it to recycle tapes by setting up a retention period of time, and then P5 will start to mark tapes as recyclable once the data on them comes outside of a time range that you've specified. So if we just take a quick look at that inside of the user interface for P5, if I go back to the backup plan that we configured a few moments ago, actually what I'm going to do is I'm going to physically switch off the tape drive because it's making a racket. And if I double click on this backup plan, then you'll see this is the configuration that we already did. So we did the backup tasks and the backup events. This blue stuff at the top here, these are tabs. So this means that our backup plan has got 2 tabs. One is called General Setup, which we already looked at. And then there's another tab called Additional Options, where we have some additional options for this backup plan. So under Additional Options, there are a couple of drop downs. First one is, do you want to always append the backup data to the volume which was last written? So this means in the case of tapes, it will always add data to an existing tape until it's full before starting a new one, as opposed to this option, which means every time the backup runs, start a new tape or volume, force new tape it will start one each time you do a full backup. So a full backup will also always start on a fresh tape. And job timeout waiting on volumes, this basically means if you have a job running which is looking to write to a volume that's inside a particular pool that the backup plan is specified to write to, and there are no volumes available because somebody needs to push a tape into a drive maybe, how long will this job wait before it errors? And the default is it will wait forever. So the job will sit in the job monitor spinning saying, I need a volume in pool tape backup, or whatever the pool is called. And when you give it one, then it will start running, or you would have to cancel the job because you decided that's not what you wanted to do. So if you want, you can have that sit there for a day and then cause an error, the job with error, or an hour, or whatever you want. The default is always unlimited. The recycle policy is what I was just talking about on the blackboard. So the default is 28 days. So that means that this backup plan, when it writes data to a volume, it will always stamp that volume with a date 28 days ahead in order to say the data that's just been written to this volume needs to be retained for 28 days because that's what the backup plan asked me to do. And of course, you could increase this to be 2 months or 6 months or a year. So the result of that can be seen visibly, because if we look at the volume, the tape volume that we wrote, we'll now see that it has an expiration date column, and the expiration date is actually 28 days ahead of today. So that means that today we wrote some data to this tape which needs to be kept on this tape until the 17th of June. But of course, if I go write this tape someday in the future, like next Wednesday, then because the backup plan says 28 days, the expiration date would get moved to be 28 days ahead of next Wednesday. So every time a tape is written, the expiration date is moved forward to accommodate the retention figure set in the backup plans that have written that tape. So if I had another backup plan that says keep the data for a year, and I do a backup to the same tape, then the expiration date on that tape would be a year ahead of now. So the way that that works with regards to what we were talking about here, excuse me, is that you have to plan out your backup so that you've got repeating full backups going across your scheduler. So you might say do a full backup every 3 months, and then say that you want to retain your data for something like 3 months, and that would allow after 6 months for the oldest tapes that you've been writing to become recyclable and be overwritten as a backup job requires fresh volumes within the pool that it's writing, but doesn't have any available. Yeah, so it's a relatively complex kind of idea to put across, but the important thing to remember is that there is a retention date set in the backup plan that will affect how long a tape is held on to once it's full, until the tape becomes recyclable and available to be recycled by the system. There is an alternative way of working with the retained data, which is to be, rather than having to schedule full backups to repeat, and this is what we call the traditional backup, we can do a progressive backup whereby the system will automatically resave any data on tapes which the system would like to recycle in order that those tapes can be effectively overwritten and reused. That's called progressive backup. And a progressive backup will automatically include in incremental backups extra data needed so that older volumes of data can be recycled. Okay, so what we've done there is we've done a backup to a tape by creating a pool, which we called LTO backup, and then we made a physical LTO tape a member of that pool by labeling it. And when we labeled the tape, it showed up in the volume list, which is the single volume that you see here. If we were working rather than with a standalone LTO drive, but with a tape library, we would add the tape library to P5's configuration by using the storage manager section here, and we would say add a new tape library. And that would give us a wizard, much like the one that we had when we added the standalone drive, and then it would list any tape libraries that were physically connected to this host, which there are none, so it doesn't see any. Now, a tape library works in much the same way in terms of P5's configuration as a piece of disk storage. So instead of having a tape library, what we can do is we can make a folder, in this case on the desktop over here, we'll make a folder and then we will create disk-based volumes in that folder. And that folder will behave like a tape library insofar as it has some number of slots inside of it, just like a tape library, and tape drives inside of it, or virtual tape drives, and it has access to a bunch of volumes, which are like virtualized tapes. So let's do that now, and then let's do another backup to our disk storage instead of to a physical tape. So I'm going to click on the new disk storage button down here, and I'm going to make a folder. In fact, I can make the folder through the P5 interface. So on my desktop, I'm going to browse via users, David Fox, desktop. I'm going to make a new folder. I'm going to call it P5 disk lib. And I will choose P5 disk lib. Actually, these are disk libraries which I created earlier, so I'm going to remove those and just do that again because there was already some data inside of those disk library folder. So desktop, make a new folder called P5 disk lib. So it should pop up again, and then select it. So you see the full path to this folder on the desktop shows up over here. And I get to choose how much space I want to make available via this disk library. So I'm going to say I want to make 20 gigabytes available. And again, I don't want to do any automatic labeling. I'm going to do the labeling and the creation of the pools myself. So I now have a disk library, which is pointing at the disk lib1 folder. So I'll delete the other folder because I'm not going to be using that now. And if I double click on this disk library to edit it, there are three things that you can go back and change. The first one is the number of container files. So this is basically the number of volumes that can exist within this folder. Excuse my noisy cat. Is 5. So we could this disk library can accommodate 5 volumes, and each one of those volumes can be up to 2 gigabytes in size. And at this point, if I wanted to, I could increase this. I could say, actually, I want 10 virtual volumes in this disk library, each of which 2 gigabytes. Obviously, in a commercial environment, you wouldn't have 2 gigabyte volumes. You'd maybe have 500 or 1 terabyte volumes to give yourself decent sort of chunks of storage across each of the volumes. And these, of course, can be used for either backup or archive data. Given that tapes are now 12 terabytes each, so a tape volume can be 12 terabytes if it's an LTO, you probably want to make your disk-based volumes at least 1 terabyte so that you don't have too many volumes to across a chunk of storage. If you want to provide 100 terabytes of storage, then that would be 100 volumes. So you can pick the size of each volume. And down at the bottom here, it will calculate the total size, which will now be 20 after we've made this change. The volume used for licensing works out that one of the things that you purchase when you're buying P5 is a media management and storage license. A media management and storage license either provides you with 1 slot inside of a physical tape library, so a physical slot, or it gives you 8 terabytes of disk space or cloud space, and we'll come to cloud shortly. So therefore, you will basically get 8 terabytes of space, and then you will use 1 media management and storage license, and then if you go over 8 terabytes, you'll start to use the second one. So you can decide how you allocate those licenses across physical slots in tape or virtual tapes on disk or cloud storage. So I'm going to apply this change, and it warns me that I'm increasing the number of container files, and I'll have to label volumes to actually make use of that additional storage. And then we'll close it. Okay, so now we have a disk library. This folder is currently empty because we didn't yet create any volumes inside of it. So let's leave that there. So what I need to do now is create a pool specifically for the type disk rather than tape so that we can create some volumes. So we'll create a new pool, and we'll call this one disk backup, and it will be used for backup, and the media type will be disk. So I will apply that and close it. So now we have a new pool but it has no storage because there are no volumes. But as with tape, I can start to create volumes by visiting the storage device, in this case the disk library 1, and using the label button. Now the label button looks different. With a standalone drive, we didn't have any slots because there's just a single slot effectively in a standalone tape drive. But here we've got 10 slots because that's how we configured our disk library. So I can now choose some subset of the slots available and choose a pool to begin labeling volumes. So this interface that you're looking at now looks exactly the same as a physical tape library. With a physical tape library, you will, after you've added it, you will see the 8 or 12 or 24 or however many slots listed on the left-hand side. And for the interface for labeling, you get to choose which slots you want to label tapes in. With a tape library, the unlabeled medium will indicate the space over here where it says unlabeled medium. It will tell you whether the slot is empty or occupied, basically. So you'll be able, if you've got a 24 slot tape library, you'll be able to tell which slots have actually physically got tapes in, so that you can choose the right ones to label. So let's continue with this labeling job. If I hit the label button, it says, do you really want to label slots 1, 2, and 3? I do. And then it will flick to the job monitor button so that I can see that job running. So you see that labeling job is already completed because it's running on the disk storage. What it will have done is physically create me 3 volumes as folders in the disk library. And if I look under, if I look under volumes, you'll see now, if I sort by ID, the first volume, ID number 1, was our tape, and then the 3 that I've just labeled are these 3 here. And if I look at the pool, I can see that the disk backup pool has got it's got 3 volumes inside of it, which total 6 gigabytes in size. So 3 volumes, 2 gigabytes each, 6 gigabytes. So I could now make a backup plan that will begin writing data to the disk pool as opposed to the tape pool, and it will otherwise work in the exact same way. In fact, what I could do is I could go and modify the backup that we already created over here, and I could add a new event in here if I wanted to do a full backup to the disk backup pool. Okay, so it's going to it's going to write all of the data again, but to the disk backup pool, and then I could run that backup event manually now, and then that will run in the job monitor just as the tape backup did, except that it'll be faster because there's no tapes to rewind and move around and so on. But otherwise, it's behaving in exactly the same way. As far as the backup is concerned, it's just writing data to a volume, and whether that volume is a tape or a disk-based volume, it doesn't make any difference. It's just writing data to a volume, and the index will work in exactly the same way. So using this mechanism, you could have backups running to disk, that disk basically can be any disk storage that is mounted on the P5 server. It has to be on the server rather than the clients that P5 can write to. Now, once this job is finished, we will be able to see if we're looking at the full backup of the local host. If we double click into that backup event, we can see that this backup wrote data to disk backup number 1. That's the volume that it wrote to. So that basically, we can go find that volume in the volume list. So if we look under volumes, then we have got disk backup number 1, and you can see that there is now 700 megabytes of data on that volume as a result of the backup that we just did. So the volume ID 10,002 is the one that relates to the physical folder on the storage. So that means that 718 megabytes has been written within this folder here. And if we drill in a little bit to see what's actually inside this folder, the contents of this folder is effectively managed by P5. So you don't need to worry about what's in this folder. But I want, as part of this technical training, I want to show you a little bit of detail. So if we look inside, In fact, if I switch this to this kind of view, you'll see that Archiware creates a bunch of smaller files within the folder that actually accommodates that data. So these files here are called chunks, and they are where the data is actually written. So rather than the volume existing as one massive file on the file system, that data gets put into this large file which just grows up to the maximum size that the file is allowed to be, maybe 1 terabyte. What we do is we create lots of smaller files within the volume, which we call chunks, so that we're dealing with smaller units of data within the volume, and that will make a bit more sense when we look at the way that we work with cloud storage. Okay, so let's just go back so we can see those 3 volumes. So now we have 2 different pools, one based on disk storage and a tape pool with 1 tape inside of it. And as far as backup and archive jobs are concerned, you can target the backup or archive job at the pool, and then P5 will look to see what volumes are available within that pool, and it will write data to those volumes. The way that P5 always works is that it will begin with the volume that was created first. So across, if you label 10 tapes, it will start writing the first tape that was labeled, and it will write data to that volume until it's full, and then it will move on to the next volume, whether that's a tape or a disk-based volume, and continue writing until it's finished writing. It's filled that volume, and then it will just keep going. So hopefully that's clear with regards to the configuration of pools and volumes, and also of how to create a backup plan. So what I'm going to do now is start to look at the archive module. And as part of the archive module, we will need to configure a pool specifically for archiving rather than backup. And we'll also look at the use of cloud storage for archiving. So I'm going to configure a couple of cloud buckets, one in Amazon S3 and another one in Backblaze B2. We will label some volumes and connect up cloud storage, because the pools and volumes infrastructure within P5 also applies to the way that we work with cloud storage. And so we will have a cloud-based pool which will write data into one of the cloud services. But before we start doing that, I'm going to configure some disk volumes for use with archiving, so that we have some storage, simple storage available to write to, and then I'll create a basic archive plan so you can see how the archive workflow fits together. So let's move across to the archive tab now. And under the archive tab, there's a lot in common with the backup. So the client list, as I mentioned earlier, is the same list of clients, so the same list of places that you can recover data from or restore data to. And then the storage manager, where we see our disk library, is also common between backup and archive. The tape drive is also common. You can see we have our Tandberg Halfite drive. We also have 2 virtual tape drives which exist inside of disk library 1. So disk library 1 here has 2 virtual tape drives inside of it. Cloud service we haven't covered yet, but that's also shared between archive and backup. The pools and the volumes are shared between archive and backup, but at the moment we don't have any pools for usage type archive. Remember, a volume can only receive data for either backup or archive data. It can't have both. The reason for that is that archive data is kept forever, whereas backup volumes are often recycled to make way for newer data. So it doesn't make sense to have a pool that can receive both archive and backup data. So we need to make a new pool here. And this pool is going to be called, we'll call it archive disk. It's going to be used for archive, and the media type is going to be disk. And click apply and close. So now we've got another pool which has no volumes in it. So I'm going to go back to my disk library. I'm going to label, and the disk library shows me that the first 3 slots are already taken by the backup volumes that we created. So let's create 3 archive volumes. So I'll choose the archive disk pool and hit the label button. And as I said earlier, the labeling on disk is pretty quick. So if I go visit volumes now, I'll see my 3 archive volumes that have just been created, which relate to the these 3 folders that have been created on the disk, and the archive pool now has 6 gigabytes worth of free space across those 3 volumes. Okay, so what we can now do is go and create ourselves an archive plan to start to get basic understanding of what an archive plan is. You'll see an archive plan is somewhat more complex than a backup because it has 6 different tabs going across the top. So I'll give it a name. I'll just call it Archive A for want of a better name for it at this point. So Archive A is the name of our archive workflow. And the basic settings for an archive plan is that it needs some target storage, so it needs a pool to write to, and there is only one archive pool created so far, so that's the one that it's picking. And it also needs an index. So in the case of backup, you remember that there was a backup index created per client. So when we go visit the Restore tab under backup, there are 3 backup indexes because we maintain separate backup index for each of the clients that we're backing up, and they're separated. Under archive, we'll see that there is a default archive index, and that's the one that the archive plan has chosen for us by default. Now, it is possible to create multiple archive indexes, and there are various reasons that you might want to do that. So let's just understand what an archive index is. So remember, the backup indexes were basically when you've got data that's come from a disk that you've backed up, everything that's backed up goes inside of a backup index. An archive index is basically the same sort of thing, index. Then you've got this one called default, which is created when you install the software. So there's a default database, and that's fine. By default, everything that you archive will go into that database. But you could have different, if you were doing archiving and you wanted to separate out and have separate indexes, maybe you'd want to do it by year. So you could maybe have a 2019 and a 2020 archive index. And for the period of this year, you'd use this one, and providing you knew which year you wanted to go searching for some old data that you'd archived, you'd look in the right archive index. Or maybe you've got different clients. Maybe you do design work for Nike, and maybe you do some work for Adidas, and you want to basically archive all of Nike's stuff in one place and all of Adidas stuff in another place, and various other brands or whatever that you look after, so that if you're sitting down with the customer and you're doing a search and locating archive data, you're only looking at that customer's stuff. You're not searching across multiple clients' data at the same time. So there are various reasons why you might want to create additional archive databases, but it might be that you're happy to just stick with a single default archive database. If you want to create additional archive databases, that's actually done via the advanced options under manage indexes down here, which I'll come back to if we get time later on. So default archive is the one that we're picking. The file filter, again, same as the things that were applicable to the backup plan. You can create a filter to remove certain files when you're archiving. I'll have to come back and show you how file filters are set up. And then if we apply the changes, you can see that there are various other aspects to an archive plan. So I'm just going to cover the various different ways that you can select data to be archived, because unlike a backup where you predefine folders and they always get backed up at midnight or some point every day, with an archive you need to manually select the data that you want to archive. So you've basically got this archive workflow that you can use that's been configured within P5, that's got the ability to write out to disk storage or tape storage or cloud storage. But how do you choose what gets archived? So there are basically there are 3 ways of determining it. One is called a manual archive. So a manual archive is basically you're selecting manually folders that you want to archive within the web admin interface, and that actually happens simply by clicking on I just move that down there. You'll see under Archive, under the Archive tab, there's a manual archiving section. And if we come in here, I could click on my Linux server, and then I could click into this data share where there's some data to archive. And then I could say, yeah, I want to archive this biking folder and this clouds folder. I'm going to add them to my archive selection. So P5 via this manual archiving option here allows you to browse data on various clients and make a selection of data that you want to archive, and then trigger the archive directly from within the P5 interface. So that's one way to choose what you want to archive. The second way is what we call auto archive, sometimes called a hot folder as well. So this is basically where we archive data from a folder or folders that you nominate on a schedule. So like 12 o'clock every day, we archive the same folder, a bit like a backup. So the workflow for this would be users take files or folders that they want to archive, they put them in a particular place on the file system that maybe has an obvious name like archive, this folder will be archived or whatever, and that data gets archived at the predetermined point in time. Let me just silence my telephone. So that's the hot folder mechanism, and that is configured within the archive plan. So within the archive plan that we started setting up, you see this auto archive tab. Auto archive basically lets you say, on a given client, we pick the folder that we want to archive. Maybe it's data share, we want to archive that, always archive that same folder from this client. And then down here, we can set up our schedule, much like a backup. So you could say every weekday, we want to archive that folder at 7 in the morning or 23:59 at the very end of the day. So now we've got our schedule and our folder, and you would just enable auto start via this menu up here, and then the archive plan would run every day and archive whatever it finds in that folder. And people just need to put stuff in that folder that they've finished with, and it will be archived. Now, of course, part of that archive with a hot folder might be that you require that the P5 archive plan deletes the data once it's been archived. That's a possibility, and that's something that's configured in the options tab, which we'll look at in a sec. The third way that you can archive using P5 archive is via API stroke command line interface. So we have two mechanisms of externally being accessed by other software. Up to version 6, there was a command line interface which was used to tell Archiware to do stuff from other software. And then in version 6, we have a web services REST-based API that's accessed via HTTP, HTTPS. So there's a bunch of third-party products which use this mechanism for talking to P5. If just to give you an example, if you go to the Archiware website under partner solutions here, there are many third-party products like Kino, asset management type products. If we just pick CatDV as an example, CatDV is a DAM stroke media asset management system for people doing video, managing lots of video footage. This can integrate directly with the archive product, so that whilst you're in the CatDV software, you can point at a video project that you're working on and say archive this, and that will pass it back to P5 to be archived to disk or tape or cloud, or however P5 has been configured in a particular archive plan to do things. So back to the interface here. There is an integration included inside of P5 version 6, and that is called the P5 Companion, which we will look at. The P5 Companion is basically an app that runs inside of Mac, Windows, or Linux. So it's a desktop application, and what you can do is you can drag files from your Windows Explorer or your Mac Finder directly into this app. So basically you can submit files or folders to be archived, and then you can hit a button to trigger the archive to run, and everything will happen inside of this app. So you don't need to use the web interface for P5. It will archive the files that you've asked it to archive using the API, and actually the files will get replaced with very small files that we call stub files. So these become stubs, which you'll understand when you see it. And then what you do is you can drag the stubs into the restore tab of this P5 companion app to have them replaced back with the original files. So this gives you a workflow that your desktop users can use directly to archive without having to interact with the more complex P5 backend. Okay, so how are we doing? I'm just checking in case anybody's asking me any questions or telling me anything that I need to respond to quickly. Somebody's got to go because they've got some urgent work to do. Right, so let's just run through in a bit more detail the configuration of our archive plan. So we covered auto archiving. The general tab is mainly for configuring the index and the storage that we're going to use. You can put users that are logging into P5. You can create multiple users and you can put them into groups so that you can limit which archive plans are available to which groups of users. And over here in the options section, we've got verification and whether we delete files after archiving and whether we do full or incremental archiving, which I just want to cover off. It's 5 minutes to 11, so I will close this down on time at 11, and then we'll pick up at, well, I'm talking about British summer time, so we'll close in 4 minutes, and then two hours later we will reconvene. So that will be what is it, 11, 12, 1, that'll be 1 p.m. in the UK. So verification and delete files kind of go together. If you want to have the archive plan delete the files or the files and the folders together from the paths that you've archived, then we can do that. But obviously you need to be fairly sure that the data that you've archived is safe. Therefore, you might want to include a verification of the data. Very often this is used with LTO tape, and we will either reread the tape and compare it with what we archived on disk to make sure everything checks out, or we will write MD5 style checksums for the data that we've archived on the tape, and then we will rewind the tape, reread the files from the tape, and then make sure that they still match the checksums. So we basically read the data back and established that it is valid. If the verification checks out, then you can have us delete the files, all the files in the folders, or if you're using this archive plan with the P5 companion app that I was just talking about, then you should have it create stub files so that people can recover data without having to use the index. And I'll run through how that works after our lunch break. Finally, the archive level, much as with a backup, the default is full, so that means that whatever folder and data you give us, we will always archive it, even if we've previously archived it and have it in the index and it hasn't changed. Or you can choose to do an incremental archive, whereby we will look in the index to see if each file that's being archived has previously been archived, and if it has, then we won't archive it, but we'll create a pointer in the index to that previous copy of the data. So it's kind of a deduplication feature that saves having to write duplicates of files onto the storage. So in order to kind of get things rolling, what we'll do is we will do a simple archive of some images, but the final two tabs here are relating to the generation of previews and the ingestion of metadata. So we will set both of these up so that whatever data we archive, we will get previews, by which I mean thumbnails of the graphics files that we're archiving. So we can see those when we're looking in the index, we can see what the file looked like that we archived, and also ingestion of metadata over here, which means that if there are any metadata like EXIF, IPTC, all of those schemas that embed data within media files, we can extract that and put that in the index so that that is also searchable. So I've got some JPEG files that have got captions inside. So we will ingest the captions from the JPEG files, generate previews, and archive the JPEG files, and then delete them from the file system so that we can see all of those metadatas and previews in the index before we restore them. So we were looking at an archive plan that we just configured. Up to this point, I'd been talking a little bit about filters. So I thought, because you can attach a filter here, so I thought now would be as good a time as any just to show you where these filters are configured. So they are configured down here in advanced options, down bottom left under file filters. Starts off with no file filters configured in a new installation. So we create a new one, we give it a name, test, and we basically describe conditions. A condition could be something like file name ends with .tmp. So there's a condition, and then we can add that to one of two boxes. We can add it to the exclude, which will exclude any files ending with TMP from the backup or the archive that this filter is attached to. Or if you attach to the top box, then as it says on the tooltip, files, directories, or complete paths matching the expressions will be archived or backed up. So that means that if we add it to the top box, then only temp files will be archived or backed up. If we add it to the bottom box, then it means everything except temp files will be backed up. So the bottom box is probably more useful. So you can do file name matches like that with contains, starts with, ends with. You'll notice that what goes into the actual box here is basically what is used in the Unix or Linux find command. So there is a command which is quite familiar to those people that understand the Linux and command line, also available in macOS and so on. It's that kind of command that is being entered in here. So we can also match on paths. So that means that you can match on a path which begins with users David desktop or something like that, and then I could say any path which starts with I want to exclude, like so. You can also match on modification dates. So if we said a file has been modified, is newer than 7 days ago, basically is newer, means that it's been modified within the last 7 days. And you can also match on kilobytes, smaller than or larger than a given size. And if you add multiple terms to the box, then they will all need to be true in order for the file to be excluded. So, but you can have multiple file filters. So basically you set up your file filter. Let's just remove that term there. So this is going to exclude temporary files, and it's called test. There is an expert mode up here, so you can type kind of raw find commands into the two boxes, and you can use regular expressions and things which aren't available from within the graphical interface here. And then back to our archive plan, we could then, having set up a filter called test, we could then assign it to this particular archive to exclude temporary files. So that covers off the filtering functionality within P5. And of course, earlier on, we were configuring a backup here under backup plan. And it's possible to attach the filter. As you can see, there's a filter column here on the backup task. So for each backup task, this is the local host and this is the Linux backup task. Within here, there is the option to choose from any of the filters that you've set up. One other thing it occurred to me to clarify, which I'll do here, is the clients and servers architecture. So it's possible to have P5 clients and a P5 server. And what we have set up, just to illustrate in the training today, is that I've effectively got a LAN with 3 different hosts on it. P5 is installed on each of these hosts. So we've got 3 installations of P5 that you saw me do at the outset. We've got a macOS, we've got a Linux, and we've got a Windows 10 installation. And what we did was we just made an installation on Linux and Windows 10, but we didn't assign any licenses to them. We assigned a license to the macOS 10 installation, that makes this our P5 server. This is the one that we've paid for and attached a license to. What we then did was we added clients. So we added a client, for a Windows client, and we added the Linux client into the configuration on the macOS 10 machine, such that the Windows and the Linux machines are available to us to select files and folders from storage. So the idea is that up here you might have your tape storage connected to this Mac, as we did, and then there is of course a disk storage attached to this Mac, but there's also disks and storage attached to these other Windows and Linux machines. And of course we made a backup plan that backed up the local storage up to the tape up here, but also some of the Linux storage was also backed up to the tape. So basically we selected some storage from one of the clients down here and some local storage to back up. But the two machines at the bottom, the Linux and the Windows machine, don't require licenses. What you need are licenses on the macOS machine in order to allow you to add two client machines. So normally when you buy a P5 license, most of them include 4 server client licenses. So that means that we'd be able to add 2 further machines to the list of clients before we've depleted all 4 of our server licenses up at the top here. There are 2 types of client license. There's server and there's workstation. So a server license is required if the client machine, like this Linux machine here, is running a server OS, and a workstation license is required if you're running a workstation OS. So the Windows 10 machine down here, that's a workstation OS, so that could use a workstation license. And then the Linux machine, Linux is treated as a server operating system by P5, so that one requires a server license. Like I said, if you buy most of the common P5 bundles, include 4 server licenses. Okay, and they don't include any workstation licenses, but you can buy additional server or workstation licenses to bring up the total to the total number of machines that you need to have in your P5 infrastructure. Of course, this is in my case here, this is a local area network that these machines are connected via, but it's just TCP/IP networking. So you could have a wide area network over here connecting you to another office where you've got hosts with storage attached and P5 installed, and there's nothing to stop you adding this remote P5 client up here so that you can access data on a machine at a remote office. Okay, so hopefully that clarifies the clients and servers. So what we've done a little earlier on was we created a archive plan. We've got some disk storage prepared for this archive plan to write to, because we created a pool called archive to disk. I'm just going to reiterate what we did a little bit here. So we created this pool archive to disk, which has got 3 volumes inside of it. This is a disk-based pool. Those 3 volumes are these archive disk volumes with IDs 5, 6, and 7, 10,005, 6, and 7. Those are located physically in these folders here. So we've got the volume IDs. Let's just go back to there. So 5, 6, and 7. These are the folders that relate to those 3 volumes that are able to take archive data. And yeah, we've got our archive plan here. And we configured it. We've got auto archiving set up, but we didn't actually enable that to run. So we can use this to do manual archiving. We are not deleting any of the files that get archived, so I'm going to change that to delete files, just so we can see some deleting going on. And previews, I will set that up now because it's quite simple to set up, and then we'll come back to metadata. So previews allows user-defined preview generators. So what this means is that when you're archiving a file, so for example, I've got a folder here with some sample images in it. So this biking folder, for example, has got some JPEGs in it. So let's say these are very large files that we're going to be archiving. And I want to generate thumbnails of these files. So when I'm browsing in the index, I can see small thumbnails of the files that I might choose to restore the originals back from. So the preview generators, you can use any piece of software that you can write a script that can generate a preview of the given file type you're interested in, and then return that preview back to P5. There are some built-in preview generators which use some third-party plugins that are listed down at the bottom here. So you see next to third-party plugins, it tells me that FFmpeg and ImageMagick, which are two open source pieces of software, both of those tools are installed, and it tells me what the versions are that are currently running. So if those tools weren't installed on this macOS operating system, then there would be nothing showing up at the bottom of the window there. There are various ways of installing these two pieces of software. On a Mac, I would strongly recommend using something called Homebrew. You just Google Homebrew and go to the first result, brew.sh. This is what's called a package manager for macOS that allows you to install a lot of open source software into your macOS installation quite simply. So I won't go through installing it, but this is a good way to get ImageMagick and FFmpeg. There is a tech article on Archiware's website that runs through that in a bit more detail. So those two tools have been installed on this Mac via Homebrew. What I'm now going to do is click New here to create a user-defined preview generator. And there are two presets, one for FFmpeg and one for ImageMagick. Just to tell you what these two bits of software do, ImageMagick is all about rendering previews, well, converting images, so static images, and FFmpeg is kind of like the video equivalent, which is able to take many different video formats and codecs and containers and convert them into other codecs and containers and resolutions. So we use that to create small thumbnail style videos of the high-res videos that you might be archiving. So let's add the ImageMagick preview generator. This is kind of all preset when you choose ImageMagick at the top. So basically this preview generator will generate previews for all of these file formats, and I'm particularly interested in it doing JPEGs, which are covered here. And then it will generate, and it says here this requires ImageMagick to be installed. It will generate thumbnails of the resolution that you pick here. And if I hit apply, that will add the ImageMagick preview generator to the list. And then I will also add the predefined FFmpeg preview generator, which will take files of these file types and generate 320 pixel wide videos of the original files. It's worth noting that if you're going to be archiving a lot of high-res 4K, 6K video, huge files, then an hour-long 4K video, if you're archiving it, might take a long time for FFmpeg running on your P5 host to render a 320 pixel preview of that file. So FFmpeg has a command line, and you can tweak the way that FFmpeg is being called here to maybe just render the first 10 seconds of the video at a low resolution, so you get a look at the video without having to transcode the whole thing. And actually that would be done by just adding -T10 into the parameters for the way that we call FFmpeg. That's what I normally do, at least if I'm doing demos, so that I don't create a lot of load on the P5 server. So I'm going to apply that one. So now we have the ability to generate previews of these file types and these image file types at the top. So I'll apply that change. Okay, so we can now use this archive plan to archive some images and then see what the results are in terms of looking in the index, and then we'll look at other ways of getting archive data selected. So I'm going to close this down. Now under the archive tab, you'll see the manual archiving selector that we saw earlier, and this will actually allow me to browse and archive some of the images in this folder here. So let's say I want to archive this biking folder here that's sitting in a folder on my desktop. So to get to that one, I would go via localhost and then users David Fox, desktop, that folder, and I'm going to archive the biking folder. So I'll add that to my archive selection. I could add other folders if I wanted to. I'll hit the archive button, and then essentially this lets me choose from one or more archive plans that I've got configured, but there's only one configured, and I'll hit the start button and then monitor to view the progress of that job. So this is running 2 disks, so it'll run quite quickly. And importantly, what this will do is generate some previews. So you can see it's finished running. If I double click to look at the detail for the job, you'll see that part of the information is saying that it's created 10 clips. These are the previews that have been created and stored away in a folder alongside the index database. So the result of that is that if we now visit our Restore tab and look in Archive and this default archive index, in here we will now see the path down which we archive the JPEGs, and when we get to the JPEGs folder we will see previews over on the right hand side, and we can raise the detail level there up to 256, which is the size that these have been stored at. And so we can now, if we look on the file system, because we configured the archive plan to delete the files as they were being archived, you'll see that they've gone from the biking folder and they are now contained within our index and contained within our storage volumes on disk. If I wanted to recover some of these, I could select them in here or via the list here. In fact, let's just recover all of them. Add those to the restore selection. Restore to, I won't choose a different folder, so they will go back to the original location. It'll figure out how many files, how big, and which volumes are required. And when we're talking about tapes volumes, it'll tell us whether they are available online or not in terms of being in the library or the drive. And the disk volume is online because it's on an available disk. So we'll hit start, and then before I could even click back into the Finder, you see those images have come back. So they've all been restored. So the index will display the thumbnails that are created by the preview generator. Those are also visible by double clicking on any of these files within the index. You will see a full-size version of the preview, also a table that will tell you every time this particular file at the particular location it's stored at has been archived. So if it's been archived multiple times, you'll see that in the table. You'll see the preview, and if this was a video file that we'd archived, this will be a small web video player that will allow you to play and scrub through the small video file that was created at the point of archive. And there's a restore button directly within this window to restore. You'll also see that there are metadata fields. There's one default metadata field called description, which is stored by default. Within this window, you could type in a description and apply, and that will actually store the description field away in the index for that particular asset, so that if I come back to it later, I'll see the description has been stored. There are 2 views here. There's a gallery view, which is switched on and off via this button here, and there's an information view, which is going to display the larger preview and all of the metadata fields. You can add more metadata fields to a given archive index, so you'll see the road bike shows up in there. So you could manually enter metadata if that's going to be useful. And you can also use the view button over here to choose to add this description metadata field to the column view. And then if I click back down, because I've been taken back to the top of the directory tree, then you'll see the road bike text will appear in the column view, and then you could search by that field and so on. You can also search within the archive index, much as you could within the backup index, for file names, dates, sizes, and metadata. So if I search for road, I will find my road bike illustration. So what's a more useful way of utilizing the metadata storage within the archive index, though, is to actually automatically set these metadata fields based on the assets themselves that you've been archiving. So in a moment, I'll show you how to do that, that process. Okay, so that's how you would do some archiving directly within the web interface by going into manual archiving. In a customer environment, it's not particularly useful to have file systems listed in the way that you see here. where localhost is showing me all mounted volumes, and then I can also click into Linux and see maybe the data share. The data share on the Linux server is actually mounted on the Mac desktop here. So this is the same folder. It's being shared via SMB on the Linux server and mounted on the Mac, because shortly I want to show you how to archive from shared storage. So when you're browsing manual storage for manual archiving in here, it's possible to customize the list of file systems which are displayed so that the users of this particular P5 installation see share names and things which are interesting to them, useful to them. So for example, rather than seeing the whole of the Linux file systems like this, it might be that I just want to show the data share listed in this area. So, surprisingly not, I'm going to show you how to do that. So this is done via this section under advanced options called access to indexes. And under access to indexes, you will see some items that are listed as file system access. So there's one for localhost, there's one for Linux, the Linux client, and there's one for the Windows client. And if I double click on one of these, you'll see that by default, it provides access to the root level of the file systems attached to this host, and it's only visible to administrator users anyway. So if I was logged in as a non-admin user, I wouldn't see these pieces of file system. So I can create a new piece of file system access, and I could maybe disable the existing one. So if I disable that one so that we're not seeing the top level of the Linux machine, and then if I add a new one, and I call this, I'll give it the same name as the data share, as the as the name of the share that's seen on the network, and this wants to be an online database for the Linux client. Okay, so online database means live file systems for the Linux client. And I don't want it to go to the top level. I want it to go to this data share, which is a folder off the root level. And I don't want to restrict this just to administrators. So if I apply that and close it, I get a new data share item in the list here. And if I now click on manual archiving, instead of seeing Linux listed, I just see data share, which takes me directly to the area that's interesting to me, which is the files that are contained on this live file system called data share. So you could do the same thing for localhost and just expose storage areas that you want people to see, and you can permission it based on groups, so that ultimately the users of the software, when they're doing archiving in this interface, they can see what they're expecting to see, what they know, what they understand. Okay, so that's manual archiving. And next I'm going to show you something called the P5 Companion. So the P5 Companion is an application that allows you to do archiving directly from within the operating system. So with a Finder on a Mac, or the Windows Explorer on Windows, or the whatever Nautilus or whatever it's called on a Linux distribution, which will vary depending upon the distribution that you're using. So the idea with the Archive app is that you can do archive and restoring directly within the Finder. You can grab hold of this application on p5.archiware.com download page, and it should be down here somewhere under add-ons. Here it is, P5 Companion App version 1.0. This is part of version 6 of P5, so you'll need to be running version 6 as it uses the newer API tools. And the idea here is that you're going to run the Archive app, configure it here to point to wherever the P5 server is on your environment, which in my case is locally, because I'm running the server on the Mac that I'm using as the desktop effectively. But it might be that you'd be going across the network to the Windows or to the Linux server to actually be the archive server. You need to provide the port number that we are listening on, which is the default port, and I've provided already the admin user and the password, and I need to provide the ID of the archive plan. So my archive plan that I've already configured is configured as 10,001. So I've just tapped the number in there. There's an update coming to this app that will have a drop-down menu that will show you the names of the archive plans and some other niceties included. But for now, we need the archive plan ID. Hit save, and I get a warning because the P5 Archive Companion app is designed to be used with the stub file feature whereby instead of deleting files that are being archived, we create tiny stub versions of those files that are basically placeholders that allow us to go find the original back in the P5 archive index. So I'm going to modify my archive plan, and under options, where currently we're set to delete files, completely delete the files that we're archiving, which is why that folder was empty after we'd archived those JPEGs. I'll choose to delete the files but create stub files and apply that and close the archive plan. And now if I come through the setup, it won't complain to me that that particular setting isn't set. So let's see how this works. So if I point, actually there's one step that we have to do before we can go ahead and archive some files, and that is tell the P5 server which folders users are going to be archiving from. And let me just explain why this is necessary by coming back into here. So we've got our P5 server, SRV, up here. So this is the Mac, and if you imagine it's on a LAN and you've got a workstation, several workstations that want to run the P5 archive app. Okay, so these are running the P5 archive app down here. And it may be that there is some shared storage available on the server that people are going to want to be selecting files for archive from. And that shared storage is mounted down here on the, let's say this is a Mac and this is a Windows machine. And down here, this might be mounted under /volumes, which is the standard place that shared storage gets mounted on a Mac, and it might be called data share. So there's a path where that data share is mounted from up here down on this Mac. And on the Windows, we might just have it mounted as the Y drive, yeah, under Windows kind of drive mounting. So the path where we will find assets stored up here will vary depending on what desktop operating system we're using. Linux might be entirely different and so on. So therefore, when I'm archiving some files from this folder up here, which is actually just on the Linux machine, it's just called data share, I need to tell P5 that people will be archiving from this folder. And then when it receives files from the Y drive, and like xyz.jpg that I'm archiving, it can figure out that the local path is datashare xyz.jpg. And it does this by placing some hidden files inside of this folder here and then looking for them in the Y drive to see which share it is that the P5 needs to read from. So you see there's a level of complexity behind allowing archiving from the desktop from shared storage. So basically all we need to do to make this work is to tell P5 in this instance that there's a data share folder from which people might be archiving, and then everything will be okay. Likewise, the data share is the folder actually on the Linux machine. I need to add my local desktop because this folder Ansel Nance images that I want to archive from initially is located on the localhost desktop. So the place where you go and plug these paths into P5 so that it knows where to look when people are archiving using the companion is the group preference. So there are users and there are groups within P5. There's a user up here called admin, which is the user that we're currently logged in as. They're a member of a group called admin. So all the users in the admin group will be able to archive via any paths that are configured in the admin group. And you see there's a client and path interface here, which is currently empty. So I'm going to add on the local host, I'm going to add the desktop where I'm doing archiving from. So that's users, me, desktop, apply. So on localhost, this is one of the paths that I'm expecting people to archive from. And then we've also got this Linux client. And on the Linux client, there's that shared data share folder. I'm going to add that one in there as well. So now P5 now knows about 2 locations where it might expect archive data to come from. So that little step done, I can now return to the P5 companion app and pull up this. Let's say we want to archive these images inside of black and white. So currently in this version of the companion app, under the Archive tab, you have to drop a whole directory, not individual files. This will change in the next version. So I'm going to drop this folder in here, and it shows me the full path to the folder. If I hit next, the metadata fields that are available at this point to be filled in manually. So I could just type test in here so we can see the results of that in a moment. And then I hit the archive button, and it says that it's submitted a job. That job, basically this window then appears as like a virtual a job monitor, just like in the web interface. And you can see the job running at the top. I can display more information. I can see the other scheduled jobs. And when it's finished, I can see the results down at the bottom. So that job completed with a green light. So that's successful. And now if I look in my folder, you can see we no longer have the JPEG files, but we have JPEG.P5 companion stub files. And these files are literally a few bytes in size because they actually just contain a reference and a file name that allows P5 to recover the original file. So recovery of these files simply involves visiting the Restore tab, dragging in some of these files or all of these files into this interface. And by dragging them in, P5 will actually look up the files and show us any thumbnails and metadata assigned. So at this point, without these files existing on the file system, I can drag them into here and go see what they look like. I can play back a video if each of these was a video file. And then if I'm happy, I could, if I can remove any from this list if I don't want to recover them. When I'm happy with my selection, hitting Restore will trigger a job, and immediately you see those 4 selected stub files have now had their corresponding JPEG files restored next to them. And then I could either leave these P5C files in situ, or I could delete them because I'm happy that I've recovered those files. The stub files can be moved around, so there's no harm in moving them to a different location. The companion app will always be able to interpret what they are back on the P5 server. Yeah, the next version of the P5 companion app will have an option of whether or not these P5C files should be deleted after they've been restored. So you'll be able to make that decision for yourselves. So the P5 companion app makes it very easy to archive from the desktop. I'll just show you via this data share folder here. So now we are viewing data that's on our Linux client machine over the network. The same thing will apply. So if I go to my archive tab, drag biking in here and archive that, I should fairly quickly see that the P5 server will be able to convert those files to the stub files as well. Let's just look at that job running. So there's the job running, and there's the P5C files sitting on the shared volume from the Linux machine. So a single workstation can archive from storage on various different hosts, providing each of those hosts is a P5 client, and providing the path that you're archiving from has been configured within the relevant group back in the settings that we just had a look at in the group preferences here. Okay. So next we'll look at importing metadata from within the files that we're archiving. So that we are able to view that, because just as an example, I think if I open one of these JPEGs up in the preview app and look at the properties for it under IPTC, you'll see that there is some metadata associated with this image, and it might be useful that we can search in P5 archive index for hiker and locate this image of this hiker. So I'll show you how to do that next. Once we've done that, we'll look at configuring cloud storage. So we'll use some S3 Backblaze, S3 or Backblaze storage, and I'll show you how you can take the disk library and the volumes that you create inside of it and have those volumes either mirrored in the cloud or exclusively data stored in the cloud. There's 2 different ways of handling it. But first of all, let's go back to our archive plan, where the last thing that we configured was the previews here, which is how we got to have those previews of the images that we've archived. Under metadata, there isn't a direct user interface for extracting and choosing metadata within what's available within the files that you're archiving and putting it into the index. There's a couple of steps here. The first step is to go edit the archive index. So that's under manage indexes, and the archive index is this default archive index here. And via the burger menu, choose fields, and you can see here that there is a single metadata field called description that we have available to sort of add more fields to. So what we want to do here is create a field called caption to accommodate that caption information. The internal name may have no spaces or special characters in it, but the application name can contain spaces if you wish. So I'm just going to use caption IPTC for that one. I don't need a comment. This will be a text field as opposed to a drop-down menu. One row of information displayed in the UI is fine, and I want this to be field number 2 such that it comes after the description field. So you'll see that because this is a user added field, Archiware prepends user underscore in front of the name. So the internal name for this field is now user caption. And that's important because we have to use that field name in the script that we're going to write that will pump the data in. So I've added my field to P5, and I'm just checking that I see that people are asking a few questions, so I'll come to that, back to that in a few moments. So I've added the field to my archive index. So the next thing I need to do is write a script. And the script that we need to make this work, I'm going to use the terminal, and I'm going to create this script as a text file. So currently I'm in the user local AW folder. So I'm just going to use a text editor to create metadata ingest.sh, which is going to be the name of my script. I'm going to insert the text that I've copied from the text document, and then I'm going to save it. I'm going to add execute permission to my metadata script. If this doesn't mean anything to you, then you'll have to learn a bit of command line stuff. It's beyond the scope to explain all this Unix stuff, but basically you could do the same thing on Windows using a batch file. This is like the equivalent of a batch file on Linux or Unix. And finally, if I just display that script on the screen, it's using a command which it runs here. The command is mdls, which is a built-in command on the Mac. There are commands on Linux and Windows that you can use that Archiware have some examples on their website of how to do that. But the mdls command, when called like this and passed the name of a JPEG file, will return a caption from within the file. And just to illustrate that, if I just copy this command and then I provide one of those JPEGs like this one here and hit return, you'll see that it returns Columbia River Gorge Scenic Area, which I think is slightly different to what we saw in the preview app, but it might be a different field. So it's this caption field that we're recovering rather than the keywords, yeah? So it's hiker, dog. In fact, that doesn't match either. Hiker, dog, have I got the wrong file? I don't know why that doesn't match, but certainly it is recovering some metadata from the file, which is all I need to worry about for the time being. So this data here, Columbia River Gorge, is basically recovered, put into a variable by the script, and then the script outputs the name of the field that it wants that information to go into, followed by the variable that's holding the information. So it's a very simple script that will be run for each of the files that's being archived in order to fill the text information into that caption field that we created within the index. So to go attach that to our archive plan, we have to go to the metadata tab, add a new script, provide, first of all, the full path. So I think that's what I called it, metadata import.sh. I called it metadata ingest this time. So let me just adjust that. So that's the script right there sitting on the user local AW directory. And I then need to add any file extensions to this list that I want this script to run for. So JPG, I'll just check these are JPG files. They are, but of course you might also want to add JPEG and so on. And then I'll use a 0-second timeout in case this gets out of control. Apply that, and then we've got user-defined metadata import script set up. So we'll apply that. So now, if I do a manual archive from here of some of those files, so let's go browse via the desktop folder for the folder with the images in. Let's take the hiking folder. Okay, let's just go back and say archive the hiking folder. Start, monitor. The resulting little job log when the job's complete tells us how many previews were created, thumbnails, and how many pieces of metadata were ingested. So you can see here we've loaded 5 previews and 5 items of metadata. The 6 is because one of the items that we archived was the folder, which didn't have any metadata attached, and then it deleted the 5 files in the hiking folder. So if we go look in the hiking folder now on the desktop, actually what it's done is it's created stub files because the archive plan has been configured to do that, so that's fine. If we go into the index, we should now be able to see the metadata that our script just generated and attached in that hiking folder. So yeah, so you can see as I highlight each one of these files over on the right hand side, you can see the caption IPTC field has some live information in it, right? So if I were to go search for hikers in the caption field, starts with HIK, it finds those files. So you get the idea. So you can use P5 as a simple media asset management system with which to capture the thumbnails and metadata from within the files so that you've got a searchable database of all the assets that you no longer need to have residing on your expensive live production storage, but completed work moved off onto tape or disk or cloud can be interrogated and searched and restored via this interface. Okay, great. So I'm just going to pan through some of the questions and see if I can answer any of these now. So question, in a pool archive with more than one tape, if one of the tapes is missing for some reason, can I access the data in the rest of the volumes? If you're writing to single tapes or volumes, then no, each file that is archived is saved once onto the current tape or volume being written. So if you lose that tape, then you can't restore the data. However, there is a feature called cloning within P5. So if I wanted to clone data being written to tape, what I would do is I would make a pool for archiving to tape. Okay, I'll call this cloned LTO for archive. Just give it a good descriptive name. Okay, so I could then label volumes in this archive pool. If I tick this box here, copy data to second set of media, then what will happen is I will need, first of all, I will need 2 LTO drives, ideally 2 LTO drives in a tape library so that the whole thing is automated. What will happen is when I label some number of tapes, we'll have, well, basically what I'm trying to say is that you'll need at least 2 tapes to do this cloning to kick off. So you'd have to label 2 tapes or 4 tapes or some number of tapes in an even number. The first time data is written to this pool, a tape, the first 2 tapes from the labeled volumes in the pool will be put in the two drives, so there'll be two tapes in two tape drives spinning simultaneously, and we will write the same data across both tapes, hence cloning. So what this means is that you'll end up with two identical tapes. Should one of the tapes become damaged, you can restore from the other good tape, and at any time you can clone and make a new good copy of the tapes. So if you have two tapes and one of them gets worn out from being restored from many times, you can reintroduce the good copy, and then you can make a new, you can regenerate a copy of it by going to the volume list. You'll see that there's a right-click option to do something called regenerate volume. So that's specifically for cloned volumes where one of them has gone bad. You can make another copy of it. So yeah, that's a good cloning workflow, particularly useful for archiving, because with archiving, you're probably going to delete the data after you've archived it to tape. So you don't want a single point of failure on a single tape that will cause you to lose your data. Just a quick note, I mentioned earlier that all of the indexes within P5, so let me just come back in here. So remember that when we were doing backups, we have a database for each of the clients that we're backing up. These databases actually exist for completeness in the AW folder. There's a folder called config index backup, and then inside here you will see folders for each of those indexes. So we are currently in that folder there. This will be in a video, so there's no need to write it down. So our local host backup index, for example, exists here as a bunch of database files. Now, whenever you do a backup of localhost, then these databases are written to the volume, be it disk or tape, that you are writing the backup to. So the backup indexes are effectively backed up each time a task runs, so that you can go recover them later if you need to. The archive indexes are not saved every time you run an archive job for various reasons. One being the size of the indexes. They might be quite large, and therefore every time you save a few files, you're saving gigabytes worth of indexes. So if you go into the Manage Indexes section, and if we look at this default archive index that we have been writing to, you'll see, if you double click on it, you'll see, as well as telling you where it's located, you can enable a backup. So you can basically say, I would like to back this up to my Windows client machine that I've configured under clients. I want to enable a backup, and I'll choose on that Windows client which folder I want the backup to be saved to. So you can automate a saving of the backup index and all of the previews that go with it to a machine on your client infrastructure that you've set up by adding clients to P5. This little bit down here allows, this is to do with Joblog emails, which I will cover at the end of this training. So this is how you can get P5 to talk to your email server, whether it's Gmail 365 or whatever, and deliver important emails about jobs that have completed and so on. In the case of archived jobs, it's possible to attach a CSV file that will give you detail on each file that's been archived. I'm trying to remember exactly what this is. Yeah, the fields in the index can be included in an email that gets sent to you in case you want to read that or include that in some other external database. So yeah, the double clicking on the archive index allows you to set up the backup. Was the main point that I wanted to make there. So the first thing to know about cloud services is that you have to go visit the cloud vendor's website, create an account, put in a credit card, create what's called a bucket. I think most of these cloud services refer to a unit of storage into which you can start to place objects as a bucket of storage, or a bit bucket. So here I have a Backblaze B2 account, and in this tab here I've got an Amazon S3 account. In both instances, I've got a bucket called P5 Training now live. You can see the bucket is currently empty, so there's no objects. The same goes for the Backblaze bucket. If I do an upload download to it, then I have to log in and out again. Let me just do that. These things expire quite quickly. I'm hoping these stay live long enough for me to show you when we start to put objects inside of them, you see, so we can actually see within from the cloud side of things. I have one remnant from this morning, so I'm going to just remove, you see this is actually a volume ID, so I'm going to remove this folder just so that we're starting from an empty place, and then go back to the P5 user interface. So under cloud service, under the archive tab, same applies for backup, so you can configure cloud services either via archive or backup. We get to do two things. We get to add a cloud service, so that looks like this, where basically we're asked to choose which cloud vendor's storage we want to set up, and then there's a bunch of boxes to fill in that allow access to the particular cloud account that we want to use. Now I've got a text file here with some credentials in, with some access keys that I've just created fresh, and I will remove after the training. Let's start with S3. So in order to access my P5 training bucket, I'm going to use this key, this secret, this bucket name, and I'll get a choice of different storage classes. Storage classes are specific to the storage vendor, in this case Amazon Web Services. Standard is the most expensive, infrequent access is IA, and you can have some level of automatically looking at the data on Amazon's side and seeing what isn't accessed very frequently and being moved down to the cheaper infrequent access tier. It's lots of different pricing variables to arrive at the right service depending on use cases. For example, I think the infrequent access, the most expensive tier probably allows you to stick an object in the cloud for 24 hours, then delete it, and you only get charged for 24 hours worth of storage. Whereas some of the lower cost services might say, well, there's a minimum of 30 days. So you put something in there for 24 hours and delete it, but you pay for 30 days worth of storage. So there's lots of small print to read to arrive at the right storage for what you want to do. So that's the basic credentials. If I apply that and then click on test connection, P5 will make the connection up to Amazon S3 using these credentials. If anything was wrong, you would know about it at this point because it would complain. Parallel uploads allows multiple concurrent streams to be uploaded via separate connections between you and the cloud service. We've found that customers with gigabit links and so on will often benefit for having 3, 4, 5 parallel uploads in terms of the total bandwidth. So if you imagine that each upload to the cloud provider might be throttled at 2 megabits, or I don't know, that's very low, but 200 megabits, let's say, then by adding a second 200 megabit stream, you've got a total of 400 megabits up to the cloud provider. And then you might find that you can go up to 4 of those and you'll get 800 megabits, but if you add another one, you don't get any more megabits. So it's really a case of seeing what works best for you with your broadband or your wide area network, lease line connection, fiber connection or whatever, tuning it according to your own experiments. So that's added the S3 service, and I can close that now, and it appears in this list. So far, all we've done is basically provided credentials and a place for Archiware to store stuff, but that's as far as it goes at this point. So if I wanted to do a manual configuration of some cloud storage, much of this will already be familiar to you. So I first of all would create a pool. So this would be my AWS pool, for want of a better word, for archive. And it's going to be used for archiving. And cloud doesn't show up in the media type. So you're first archiving to disk, but you're then replicating to a cloud service. So basically everything that goes onto the disk volume, which is what we had here, remember? So we've got volumes here and all the data that sits inside of them. That will get written to disk. It will get copied to the cloud. So at that point I can click the cloud service that I want it to be copied to. Once it's been copied to the cloud, I can choose whether or not I want to keep the local copy as a clone. So in that case, you can think of it as a disk-based backup or archive with an additional copy in the cloud, so that if anything should go awry with your local copy, then the system will recover those bits from the cloud. If you just keep it, if you untick this box to say don't keep the local copy in the cloud, you get some warnings, but basically each chunk of data, which is like a unit of data stored within one file, will be copied up to the cloud and then deleted locally. So the local storage doesn't need to be able to accommodate everything that you're archiving. It's just used as a transient kind of caching area where we're writing down chunks of data before putting them in the cloud and then removing the local copies. So as you can see, when we switch off keeping the local copy, it says that your data will be less secure, slower to recover, and may cost more money because you'll be recovering from the cloud all the time. So we're okay with that. So yeah, that's the pool configured. So it's just like a regular archive to disk pool with the addition of the cloud service, and then us basically treating the local copy as just a cache, temporary copy of the data. So I can apply that. While I'm in here, I can set under expert settings, some of this stuff's outside the scope of the amount of time that we're assigned to this train today, but the chunk size I'm going to reduce down. So this is basically when I said that we're writing chunks of data down to disk, copying them into the cloud and then removing the local copy, the minimum unit of data is a chunk. And by taking that down to 64 megabytes, we'll have more chunks created for the purpose of this training today. It's there are various reasons explained here why you might want to fine tune the chunk sizes. Okay, so that's that pool created with the 64 megabyte chunks. I'm going to apply that and close it. So that shows up in my list, AWS Pool Archive. And what I'll do now is label some volumes. So in order to have my cloud storage, disk storage separated out from the disk library that we've already created, I'm going to go into Storage Manager. I'm going to add some new disk storage. I'll put it on the desktop alongside the other disk storage that we've already configured, but I just want to separate it out. So I want to call this one disk cloud lib. See that pop up, select it, and we'll limit to 10, and we won't label, and we'll apply that. And for some reason that didn't work. So, okay, I don't really want to restart. So what I'll do is I think I've got some free slots inside of my disk library here, so we'll just use the existing disk library rather than creating another one. Doesn't make too much difference which way around we do it. So I'll use slots 7 and 8 and label volumes in my Amazon Web Services archive pool, and we'll hit the label button and we'll let that complete. We'll look at the monitor window and you see, just as before, 2 new volumes are created with IDs of 8 and 9. So that means in this folder here, we've now got 8 and 9 listed, which are these 2 currently empty volumes. Now, if I do some archiving now to this pool, so if I go back to my archive plan and I switch the target storage to my Amazon Web Services pool, for which we currently have 2 volumes, and I then go manually archive some data. So let's just go to data share on that Linux box. Let's archive that whole folder. At the moment, my archive plan is set to replace with stub files. I don't want it to do that, so I'm just going to go back in here and say don't do any deletes so that we don't lose everything. And I'm going to go back to my data share. This is on the Linux machine. I'm going to archive this entire folder. These are subfolders, so it makes no sense to archive those separately. Archiving, archive at A, start, and then we'll see this job running. So let's have a look at what's happening. So what should happen is that the data is going to be written to disk and it's going to be copied up to the cloud bucket. So what we'll see is this task that I'm highlighting with the mouse. It's copying chunks from volume 10,008 up to my cloud bucket in Amazon Web Services. So we'll just let that finish. So it's copying. My upload speed is pretty poor. It's going at about 1 megabyte a second, but you'll see it's basically copying about 8.5 megabytes of data via one of the chunks up to Amazon. So we'll just let that finish, and then we'll be able to see what that looks like, both in terms of the local storage and in terms of what we can see in that S3 bucket. Okay, so that's just finishing up. So, oh, and it's just copying some additional metadata up to the cloud. Then it's generating clips. There's 128 or so JPEGs there, so it's generated all the clips for them. So that data will now be restorable via the Linux host. Sorry, I'm looking in backup, not archive. So if we look under backup in the data share, look at some of those files. If we look at this one here, we can see that the detail on this file is it was archived just now to this volume 10,008, which is in the AWS pool, archive pool. So on disk, if we have a look inside of here at that volume, let's flick to this view. Then inside the actual volume, we get one. This is the first chunk, and this is the first real chunk that actually has data in it. This has got 10 megabytes worth of data in it, so it never got past its 64 megabyte limit, at which point we will move on to another chunk called GF number 2, and then we would have deleted this chunk because we'd finished writing to it. Because this chunk has only got 10 megabytes of the 64 total in it, it has not yet been deleted, but it would be, because this chunk will also exist in our cloud bucket. So if we go in here and refresh, we'll see that the volume 10,008 is represented in this storage as well, and everything that's on the local disk is also in here. So here's our approximately 9 megabytes counted differently between here and the macOS worth of data that lives in the cloud. So that means that I'm not going to write lots of megabytes of data because we'll just be sitting here waiting because my internet connection is slow. But if we'd archived 100 megabytes worth of data, we would have filled up this 64 megabyte chunk. So this would go up to 64 megabytes, would get copied to the cloud, and then we would create the next chunk, and then we'd have about 40 something megabytes worth of data written into the second chunk. When the job finishes, all the chunks get copied to the cloud, but any chunks that aren't yet full up to 64 megabytes remain on the disk, so that next time we write to that volume, we fill up the remaining chunks, and then they get deleted. I'm hoping that this is coming across. I could maybe try and illustrate this in here. So basically we've got this volume, we've got this folder, which is called 10,008, which is basically just a volume ID. So we've got this folder sitting on our storage. Inside this storage, we basically have these 64 megabyte units of storage, which exist as separate files. So into here, I'm archiving, let's say 200 megabytes worth of data. So what happens is first 64 megabyte chunk is filled up. Then the next 64 megabyte chunk is filled up. So we write as many chunks as needed to accommodate that 200 megabytes of data. Should have made that 100 megabytes, but let's say it's like 4.5 chunks that need to be written to store this data. As these chunks are filled up, each one of them is being copied up to the cloud bucket, wherever that might be. In this case, it's S3. So we're copying each of these chunks up to S3 as we finish writing them. And as we do that, because we're not keeping the local copy, we're deleting them. So the 4 chunks that got filled in their entirety will get copied up. So they're here, 1, 2, 3, 4. And the final chunk that didn't get filled up, that one is also copied. It's only partially full. And then the next time we run a job, what happens is we continue writing this chunk until it's full. And then maybe we write half of another chunk. And then this one here gets copied up again as a full chunk, and then we copy the next chunk up. Okay, so hopefully this is making sense. There's lots of use of the word chunk here. Yeah, so that's broadly how that fits together. So that was manually configuring Amazon S3 cloud service, manually creating a pool, labeling volumes, doing it. That's the very long way of doing it because I want to try and put across all of the detail behind it. The other way to do it is using what we call the, if I go back to the archive here, cloud service, there was another button. So that's the button that we use to add the cloud service. There's a button that will add cloud storage in one go for us. So let's try using that one alongside adding our Backblaze B2 storage. So this time, let's pick Backblaze B2 from the list. And let's go with this key here, followed by this kind of secret passwordy element to it, followed by P5 training. And again, you could increase the number of upload streams. With my slow internet here at home, it's not going to make any difference, so that's fine. So we'll just submit that, test the connection to make sure that the credentials all check out. Okay, so it successfully connects, but at this point it doesn't label any volumes, so it doesn't actually copy anything up to the storage. Now we have two different cloud services configured. If I now use the Add Cloud Storage button, what this does is it takes the cloud service that you want to use and it takes a local directory. So I'm hoping that this works okay. So basically desktop, and we'll call this one B2 cloud. I'll call it cloud cache because that's kind of what it is. So we'll choose our B2 cloud cache as a directory. And then the only other option we have here is whether or not we want to keep a local copy of our data. So for this one, I'll say yes, we'll keep the local copy. And there's a little tech tip here that explains what the benefits are of doing that or not. So what happens now is we will create 100 terabytes worth of storage capacity by creating 100 volumes that are each a terabyte in size, ready to receive 100 terabytes of your data. So it's just creating a lot of capacity via lots of volumes within P5. It creates the pool, it creates the disk library, and it labels the volumes. And it does all of that by clicking the apply button. So the only input here is give us the name of a cloud service that you've already set up and give us a directory to store the local copy, and we'll take care of the rest, creating the volumes, creating the pool, creating the disk library. Okay, slight interjection here from me whilst editing this video. I made a mistake here. So if you are not keeping a local copy of the data being written to this disk library, then there's no need to worry about how much local storage we're using, and therefore 100 terabytes of storage is created via 100 1 terabyte volumes. However, if you are going to keep a local copy, P5 has a look at how much space there is on the disk that you are putting the directory into, and then we'll label volumes to give you, well, basically to use up that capacity that you have available on that disk. So in a moment, when I finish applying this window, we'll find that there's about 150 gigabytes of storage made available, and that's just because there was only 150 gigabytes of storage space available on the Mac that I was using to do this training. Okay. So we hit the monitor button, and there will be a job that runs, which is now running. And you see within this job, it will label quite a few volumes. In this instance, it's only labeled 10. So if we go and have a look under volumes, we will see these Backblaze volumes that have been created in a pool called Backblaze B2 Archive. So that was created for us. And if we have a look at the storage manager, this is the disk library that's been created. This has got 150 gigabytes of storage. Ordinarily, this is 100 terabytes, so I'm not quite sure why that is, but it doesn't really affect us too much. So you can see that that single click basically configured volumes, pools, and storage in order to allow us to do some archiving to Backblaze storage. So what I could now do would be to flick my archive plan over to my Backblaze pool that was just created and close that. And then I could go and do the same thing that we did earlier. I could archive this folder, start the job, and then that will result in us writing the contents of those volumes to the Backblaze B2 bucket rather than the Amazon S3 bucket. So when that started writing some data, we'll have a look and see what we can see in the B2 bucket. So you see it's copying up 97% of 600K, so there's less data there, it would appear this time. And actually that's probably already visible in the Backblaze bucket. So if we do a refresh in here, we'll see a volume ID show up. Page is still loading, but it should be the volume ID 10,010. Oh yes, and it's copying 1% so far of 8.7 megabytes. So this is copying very slowly actually. I don't know if this is my internet connection having trouble, or in which case you might not be able to hear me, or if it's just rather slow on the part of the, this is a US Backblaze account, so it's copying the data quite a long way. And this isn't loading for me either at the moment, so maybe there's an issue there. Okay, yeah, that's just finished loading. So you can see that volume is now represented in the cloud. The folders with the zeros in are there, and this is where we will see the chunk files appearing once this job is able to copy some reasonable amount of data. It's going a bit quicker now. Okay, so that job's still running. We are archiving there to Backblaze. So I've shown you how to configure storage to use the cloud. Of course, backup and archive just need a pool to write to. They don't mind whether that pool then is tape, single drive, tape library, whether it's just writing to some disk storage or whether it's writing to disk and then that's being copied to the cloud. That stuff kind of all happens independently of the actual job running. So any of the backup or archive jobs can write to any volumes that are stored in the cloud or anywhere else. Okay, so I'm going to go through configuration of email delivery and just talk a little bit about that. So you've been seeing the job monitor today as we've been running all of these jobs that you can see down at the bottom here. And you've got a feeling for the fact that the jobs sit there at the top, you can see them running, and then they drop down to the bottom, and it's about the last 24 hours, I think, that's visible at the bottom. There is a paginated list here, so there are more jobs than you can see in the first page. The jobs at the top here with the clock symbol next to them are there because these are backup jobs that we're going to run tonight at 22:30. This is because when we configured our backup, in fact, let's just click back to the backup tab, the backup plan, and you'll see up here we configured an incremental backup to run daily on weekdays at 22:30. So that shows up in the job monitor here because these are going to run this evening. You can highlight these, one or more of them, and hit start now to make them run immediately, or you can stop a running job via the stop button. So this is quite an easy place to monitor and run jobs. You can also focus on the left hand side on just scheduled jobs, just running jobs, any job. You can switch off recently finished jobs. You can filter recently finished just to see backup jobs or archive jobs and so on. You can also just look at Linux client jobs or Windows client jobs, of which there are none at the moment. So there's a lot of possibilities in here. But there's a second window available from the same menu, which is the history window, which basically just gives you a history of all the jobs that have been running within some time period, and you can filter by just backup jobs and so on. So it's the same kind of thing, but it's a complete query against all the jobs that have run on this installation since it was installed, whereas the job monitor window is just within the last 24 hours. I think it's the last 24 hours. So, and of course you can double click on these and read the information. The reason I'm going through this now is this same information about a completed backup, like this one here, this text information can also be sent to an email address that you specify via an email server that you specify. That is done by visiting the clients section here and clicking on the localhost client. The localhost client has a different set of configuration to the other clients. So if we're looking at the Linux client, for example, the Linux client is basically the IP connection information to get us to talk to this other Linux machine over the network, whereas localhost is different because this is the local machine. So it has some configuration around that, including email configuration. So email configuration, this part of the configuration is basically pointing to your email server in order to deliver mail. So if you have whether your email server is Microsoft 365, Google for Business, or whether you have your own hosted server or an on-premise email server, it would be the DNS name for that server that you would put in here, or some box that's able to relay mail. And there are standard kind of SMTP servers available for the big outsourced email providers. And then the mail sender is going to be, whoever the mail should come from. So that should be a genuine existing user or alias within your email domain. And then I think 465 is used for 365, 587 TLS is used for Google Maps apps. 25 is plain text unencrypted. So you have to choose which port your SMTP server is listening on and what kind of authentication, provide the authentication information. Once that's all set up, you could put your own email address in here, send a test email, and you should receive that fairly quickly. And that basically proves that P5 is hooked up correctly to your email infrastructure and is able to send emails. Once that's done, and you know it works, then come out of here and then visit the user preferences section over here. So each user that logs in to P5 can have its own email address assigned, and then jobs which go to individual users can be the jobs that they've submitted themselves. Basically, there are two classes of jobs which are available within P5 to send as emails. There's basically the automated, and then there's the manual jobs. So for example, an automated job would be a backup that runs at 2300 hours every day on a schedule. That's an automated job. And the job logs that are generated by this one will go to the admin user, okay? So the admin user will receive all the automated jobs. Whereas if you had a user called Dave configured in the system, and Dave does a restore, and it's his own particular job, then that one is going to be delivered to Dave's email address. Okay, so there's two types of jobs. There's the automated ones and the manual. So this email address here probably wants to be, the network admin person that's responsible for making sure that backups are running okay, as opposed to Dave just might be somebody that's, using the archive and restoring stuff out of the archive. You can, of course, create new users in this user list. So I could create Dave, password Dave, and I could say he's a standard user. He can do, he's allowed to do restores and archives, but he's not allowed to do any administration or operator rights within the system. He's just allowed to do archiving and restoring. And I could apply that, and then that user is created. At the same time, within the notification tab for Dave, I can provide his email address or my email address and make sure that I can send emails to his address. And then this table here of notification events, basically these are all the different categories of email that we can send. So for example, within the backup module, we have three classes of backup job. One that was okay, green light, one that's got a warning, so it ran okay, but it has an amber light in the job monitor and means that there is something that you need to know about that job. Maybe there's a file that was open while we were trying to read it that we couldn't read, so we didn't save it, or a job which actually errors, so there's some major problem with it. So those three categories exist across all the different modules, and Yeah, so you just need to choose the ones that are relevant to that particular person. The admin user has the same notification tab, but you probably want to leave all of these categories available. You can highlight one of these and click minus to remove it, or find it in the list and hit plus to add it back in which case I think it appears at the bottom. Yeah, so that's broadly how email reporting works. You need to think about the users, provide the email addresses, set up the SMTP server side, and then you should have everything there that you need. So synchronize. If we just write something, draw something on here about synchronize, what I'm going to do is I've got my Linux client machine, which has its data share, and there's a folder with a bunch of files inside. What I want to do is I want to replicate this folder over to the Mac, where I've got my desktop folder, and I'm going to create a folder, and I'm going to replicate that folder of images, so you can see just how a replication works. And I'm going to sort of do that daily on a schedule, so that just runs automated and keeps copying any changes across. And then I'll show you how if we make a change to a file over on the left-hand side, I want to keep the previous version of that file as well as copying the new version of the file across. So that's what we'll do first. And then I'll also show you how to do what we call snapshots, which is where the whole folder on the left-hand side, we maintain several copies of that folder on the target storage over time. So this might like be 1 p.m. and at 2 p.m. it looked like this, and at 3 p.m. it looked different again. So yeah, we will configure, this will be our, what we call the source of the data will be the Linux machine, and over here will be the destination for the data, which will be coming back to the Mac server that we are looking at right now. So there's a lot less options on the left-hand side as compared with Archive. So Synchronize is just interested in the clients, so the machines that you're going to go from and to replicating data, and then you have a Synchronize plan, which is basically a configuration with a scheduler inside of it that will copy your data for you in the way that you've defined. So let's make a new sync plan. We'll call this sync A in case we want to have sync B later. And once I apply and create the plan, just have a sip of drink, then we need to configure the source of the data, the destination, and the schedule, as I already described. So the source of the data is going to be the Linux machine. Now I have this data share up here mounted, and we have this images folder, which already has a bunch of JPEGs in it, pretty much all intact. This folder here was archived using Companion. I'm just going to delete that one because it's not so interesting to be replicating stub files. So we've got various JPEGs up here. So this is located on Linux, and if I browse on my Linux machine, I previously configured the data share to show up as a location. So it shows up in this file picker. So I can just highlight data share here, and it will fill out the correct path on the Linux machine. You'll notice that this is a bigger box, directories here, and I can have a list of directories from the source machine, from the single client. So I've got several directories that I might have being synchronized back to a single location on the target. So the target for my data, my options are, I could synchronize it from Linux back to Linux, so the data could just go between two different folders. I could go from the Linux host back to the local host, which is the Mac, or I could ask for the Linux machine to send the data to the Windows client, in which case the Mac would not be involved in the data transfer. It would just be involved in scheduling and triggering the job, and it would tell the Linux machine on a schedule to go send data to the Windows machine, but the job logs and the management of that operation would happen on the third machine back on the Mac. So that we can see what we are replicating, I'll just create a folder using the Finder on here, and I'll call it synced, and I'll browse for that folder in here. I could have created the folder in here, of course, like I did earlier. So there's the full path to the folder that we want to synchronize to. So I'll apply the changes that I've made so far. And then the scheduling part down at the bottom here requires that I hit the new button to create a new schedule. And there are two different modes at the top, which are described in the text. So a mirror will keep the target folder identical to the source, and it will delete where necessary. So that means that if I'm syncing here from, if I was just to show this folder a little bit bigger here, so let's say we've got 3 files. First time I run the sync, those 3 files, we have an empty folder to start with. So those 3 files are going to get copied across. That's great. If I delete one of these files, then if I'm doing a mirror sync, that file gets deleted over here. If I were to empty this folder, then I empty the folder over here. So that's the way that a mirror works. The other kind of sync is called an update sync. What happens with an update is that if I do a delete over here, it updates only by copying files across. It doesn't do any deletes. So update is in many ways a safer way to run, and certainly when you're testing and maybe you don't have everything quite right, it's better to test with update syncs. So that's what I'm going to do. First time we copy, of course, it's going to copy all the files across because there's no data in the target folder, so it's going to have to copy everything across. The scheduler, you can pick a date to start on, you can pick a time, so this will just run at 7 AM. So if I just wanted to run at night, I'd just put some late in the day time in here. Or you could say starting at 7 o'clock in the morning every hour through till 7 o'clock in the evening. So you could have a schedule where it repeats through the day between the start and end time. And then you could do that every day or just on weekdays, which tends to be my preference. And you can attach your file filter in here as well, and then apply that to save that into the table down at the bottom here, and apply there to save the whole job. So what will happen now, if I run this and we look at the synced folder, which is currently empty. So let's hit the Start Now button. Of course, as with all jobs, this runs in the job monitor as a sync job. If you've got email reporting configured, you'll get an email when this job completes. And it runs fairly quickly, and it copied 19 megabytes in 7 seconds. And we can see here that it's copied both the zip file and the folder. And special characters, I just noticed that there's this kind of spurious character on the end of that folder. We do the very best efforts to transfer files between different file systems because we're running on Linux and Macs and Windows with NTFS and various different file systems, as well as Synologies and QNAPs and all manner of varieties of Linux and FreeBSD. There are lots of different file naming conventions, UTF-8 and so on. We will always do the sensible thing with regards to retaining as much information and attributes and resource forks and data forks and all of that stuff that might exist on one file system but not another. So for example, old Mac servers with the resource forks, if you synchronize or move files using P5, those resource forks will get put inside NTFS file streams in the correct place, so that if you then reshare that data from Windows back to Macs, that resource information and file attributes and so on will still be in the right place to be viewed. So that folder got copied across. So now what happens if I go and if I create an additional file, like a copy of that Portland JPEG, then of course if I run my sync plan again, then what it's doing is it's comparing the source and the destination every time it runs. There's no index behind it that it refers to. It's just looking at both ends in a very optimized, fast way and working out what needs to be copied. So you can see here only 156K just got copied, which means that our Portland file here on the target folder will have been copied across, but nothing else was copied because we knew that was the only thing we needed to copy. So you could just run like that, and that's great, and you've got a nice replica going forward. If you're doing a mirror sync though, sorry, if you're doing an update sync, which is what we're doing, I could enable on this particular event, keep previous file versions, which pretty much does what you would expect it to do. So in order to illustrate this, if I go back to the source of the data and I take this fog JPEG and I do a crop so that I'm saving a new copy of that file. So fog is now, oops, fog is now this little cropped version, and we run the sync again, and then we look in the target folder, we will see that we get, which folder was fog in? There it is. So basically, wherever files are changing, like within the clouds folder, for example, we will copy across the new version of the fog JPEG, but we will create a versions folder and we will keep the previous version with a number 1 on it, and so that we can have more than one prior version of each file that's changing. So basically we add the versions folders in on the file system where things are changing, and we put previous versions of changed files in there, and there is a setting within the sync plan to say how many versions of changed files we will keep. You'll notice that these versions folders have appeared at all levels because I think the way that I've got SMB set up on the Windows machine is doing something weird with the Mac Finder DS store files. So these additional files are showing up and being versioned by P5, but we could switch this off. We could switch detection of hidden files off and so on. So don't worry too much about that. So yeah, you can make changes to files and keep previous versions using that option. Within the sync plan options, you can choose how many file versions to keep, which is 4 by default. And then off you go, you've got a copy of your source data with retention of previous versions of changing files. Obviously, in that instance, you'd need to be aware of how much storage, because if everything changes and you're keeping 4 copies, then you're going to need 5 times the source storage on the destination to keep track of all of those versions. Of course, you could schedule a mirror sync event to run maybe at the weekend or once a month, and by running the mirror, so let's just apply that change. If we run the mirror, as I said, that basically makes the destination and the source identical. So has the effect of, as you just saw, everything just disappeared, has the effect of tidying up all of those old versions of files that were being kept and getting everything back to a one-to-one kind of relationship between the two things. Question coming in. Yeah, that's a good question. This is going into the advanced options, which I'll talk about in a sec. So this is around mirroring and deleting on the destination before the copy takes place, which is an excellent question. Thank you for that. You've reminded me of something that I should explain. So before I explain that, I'm just going to cover off the cycles feature. Now, cycles is a feature of a mirror sync. So with the update sync, which doesn't delete, it can create previous file versions. With a mirror sync, which does do deletes, it can basically take the entire folder as it was at a point in time, turn that into a cycle or a snapshot, and then retain by default 4 snapshots. So it's easiest to understand this if I just show you. So basically, if I run this mirror event right now, and then we drop back to the Finder to see what effect that's having, you'll find that the current data set, which is basically these 2 items, gets popped into a time-stamped folder, 1501, so we're overrunning, and 2 folders, right? So now this snapshot will remain now until it's aged out of the 4 snapshots that we're keeping. So if I were to go make a change to the source folder, like for example, if I were to delete this entire folder from the source machine and then run the mirror sync again and then look at the destination folder after it's had a chance to do its thing, If we close the cycles folder, ignoring the cycles folder, they're now identical. The only thing in the share is a zip file. The only thing in the destination is the zip file. But because we've run it twice, we've created two cycles, one at 15:01, 1 second, and then this one here. So this basically means at that timestamp, 15:01 and 46 seconds, that's what we had in that folder. But outside of the cycles folder, this is the current copy of the live data. So the interesting thing about this is that we're not duplicating everything for every snapshot. They're not all using additional space in the cycles folder. We're using hard file system links to effectively provide pointers on the file system back to the same blocks on the disk. And so that's one way that we can do this without using additional space. The other thing that we'll do is we'll use BTRFS or ZFS file systems. We'll actually use the file system's built-in snapshot ability to create these cycles. So there's quite a lot of interesting stuff you can do there around using snapshots and synchronization in the sync module. You see there's a bunch of tabs here. The first tab we looked at, which basically determines how many cycles and how many versions to keep and whether to use file system hard links or just to copy the files and use the additional space. And it talks here about ZFS and ButterFS. Then over in expert settings, this is the deletion mode that the question is answered by. So let's just look at what it is that we're getting at here. So let's just clear my slate and pick up my pen. So yeah, if you imagine that you've got a disk with a lot of data on it, and you're replicating that over here. So of course there's a lot of data on this disk here, and let's say these disks are like almost full up to the brim. If you delete quite a lot of stuff off of this disk and then add quite a lot of new stuff, the way that P5 ordinarily does its work is that it goes folder by folder. So it takes one folder of stuff, it does the deletes first within that folder, and then it does the copy. Okay, and then it moves on to the next folder. Now, if it turns out that the first folder that it visits has a lot of data added, what could happen is it's trying to copy that data and actually fills the storage up before it's able to do the deletes that would have provided the space to give the capacity to copy the new stuff across. So there is a mode within the archive plan, the synchronize plan, that you can enable that instead of doing everything in one pass, traverses all the folders twice. The first time through does all the deletes up front so that it creates the maximum amount of free space that it can do. And then in the second pass, it does all the copies. This was a problem that customers would occasionally come into, where the sync plan would fill up the target disk and everything would fall in a heap. Because once the disk is full, you have a problem. You've got to manually delete stuff to allow the system to start working again. So this second mode is optional because it takes more time because we have to go through the whole storage twice, but it gives you more security. So it's up to you as to whether you want to do that or not. So that's that one covered off. And I'll just delete that question. And another question coming in, are mirror cycles real file system snapshots? macOS doesn't do file system snapshots, so every cycle uses space. Yeah, well, cycles don't all use space on macOS because we use hard file system links, which you will see here. So we will use, if this option here is selected for cycles, if the file system isn't snapshot capable, i.e. the Mac file systems, which was HFS and is now APFS, which does allow snapshots, but there's no API I'm aware of that Archiware can use, then we will create hard links. This is exactly what Time Machine does on a Mac to write lots of backups of snapshots to USB drives. So it's quite a good way to do it, but it's slow because every hard link has to be created one by one. So although they don't use space, they create a lot of work. So if we're running against ZFS or Btrfs, so not a Mac, this would have to be a Linux machine, then we can use real snapshots, and they will be very fast because the file system takes care of it for us. Another question, when renaming a big folder on source, is it renamed on the destination? No, it's recopied. There are various reasons for this. It's very difficult to do to transmit rename operations from source to target and get everything right. So to be on the safe side, we assume that the renamed folder is an entirely new folder, and we'll copy that across. This also applies to backups. So it's a good idea in a commercial environment not to have people changing the names of high-level folders on shared storage, because for P5 and many other products like P5, that will cause a lot of problems. So we are nearly 10 minutes over time. So I've really gone at this point through those three modules in quite some detail. And I think I'm happy if you people listening have kind of absorbed all of that successfully, then I think that's a good amount of coverage for one day. Indeed, it was a lot to cover in one day, so I'm just wrapping up this video now with a final goodbye, and thanks for watching.